very well established that when people come with different experiences, different expertises, the work environment, it has a much more richer, collaborative, innovative, as well as a creative spirit than would happen in a homogeneous group. Okay, so today we are going to, it's impossible to celebrate all the women and all the diversity in RRI. So today we will celebrate, we will talk about, and we will listen to a handful of women who have made RRI what it is today. Okay, so many thanks to all of you for showing up. Many thanks to the speakers who, very enthusiastically agreed to show up at very short notice, and for all their wonderful ideas without which this thing would never have happened. To Subbu, who's outside, arranging for something. He's our resident creator and innovator. He's done a lot of hard work. To Sachin, for all the arrangements. Vidya, Abby, Jacob, Orgho, from the computer team. To Pradeep, okay, for very kindly, live streaming our program. So let's get on with our program and let's keep shining. And we will start the day with the director's address. So the director is right now, he's in ISER Pune, but he's going to tell us a few words before we move on to the rest of the program. Okay, so there's Tarun. Hi, Tarun.
Hi, can you hear me?
Yes.
Okay. So let me begin by greeting everyone on the International Women's Day. And good morning to you. And let me add my note of welcome to this wonderful event that's being organized at Raman Research Institute. And as you all know, it's not been too long, so I'm still figuring out, but I understand this time we do have a comprehensive program and it is a public event. And I really thank the organizers for putting it together and the speakers for agreeing to speak at this occasion. And also, it's been very heartening to know that RRI fares well on the gender equity issue in terms of numbers related to other physics institutions. Yes, that's great. We have, for example, 1/3 of the representation of women in the faculty, and that's quite good. But we have a long way to go even in that, just in terms of numbers. And more importantly, numbers are just, numbers, right? So that's not all there is to this problem. The critical issue is to be able to create an ambience and work culture that allows diverse genders equal opportunity to seek their goals and contribute to the institution. And we do have a long, long way here. It's a challenge, and I really would request everyone to help move forward on this path. And, I think there's a space, so it is a message to everyone, not just women talking to women. And I don't think that's the way it should go. And also often we wonder what good does it do to have a day in the year marked out for this and for an issue that is relevant every day, right? But to me, it's just the same reason you celebrate a birthday. It's also just one circle around the sun. But, we are, sort of celebrating life. We are also living every day. But there's a time to pause at a milestone and see what we did in the last couple of years and what we should do in the years ahead. So it's helpful always to have milestones on the path. And in that sense, these events do give us an opportunity to get together and think about these issues. And the other point is, of course, women issues and then gender diversity or any diversity issue is a global and societal challenge. But what we as the Indian science community or even the science community at large and also institutions such as RRI can do is to essentially tidy up the house at our end, right? And hope to stand out as some kind of an example that inspires others. And it's very important to do so. You can't just preach this without practicing it at home. So I think it's very important, again, for an institution like Raman Research Institute to take this as an extremely serious and important challenge. And also it's also a challenge, and every challenge has its excitement also. And I think we should really look at it that way. So I will not stand between you and the lovely program ahead. So I understand that at least let me just mention the first two talks. The first is about a recent shining example of a woman in science, our own Professor Hema Ramchandran, who, as we know, passed away untimely, but it marks a very important career that is provides a kind of inspiring lead role, role model for youngsters. And interestingly, the next talk is on Professor Purnima Sinha, who has been one of the earliest to forge the path ahead, and I look forward to listening to that. And finally, I'll end on the optimistic thought that I find that I am the only non-woman speaker amongst here. And, just a thought, wouldn't it be lovely that if that were to change in the coming years? Okay, with that, let me hand back to Ranjini, and I, hope you'll enjoy this and carry something back with you from this event. Thank you, everyone.
Thank you very much, Tarun. Thank you very much. Yes. Okay. Thanks for joining us. So, Andal has logged in, and Andal will tell us about. We are felicitating Hema today, who we lost very untimely. She was a wonderful friend, a very well-loved friend. A very good scientist, and Andal, who's now in Canada on sabbatical, she will tell us about the life and science of Hema. Andal, thanks for joining us.
Thanks, Ranjini. I'll just share my screen first. Yes. Just a second, it's sharing with the half-closed screen. Yeah. Yeah. Can you now see the full screen?
Yes.
Yeah, great. Yeah. Hi. It actually gives me great pleasure to talk about Hema, especially on this day at RRI. Many of us know her and knew her personally as well. So I don't think she needs an introduction to the wider audience here. So I'll just directly go to the talk. So Professor Hema Ramchandran, Hema to all who knew her, left us on November 24th, 2020, after a long battle with cancer. The Light and Matter Physics group was started by her. Of course, it was called Optics Group then. And so she was one of the founding members of the Light and Matter Physics group, and she's a fine scientist as well. So just thinking about her life, I realized that she was a feminist, not only through her scientific work, but also through her everyday life. And she walked a path which was rarely taken by women of her times. Looking back, it has become very, very obvious to me that very few people would have done what she managed to do. So I will mostly spend time on the kind of science she did at RRI with some brief snippets of what I know about her life. Right. So this Hema had an MSc degree from IIT Bombay, and thereafter she joined BRC training school as part of getting her PhD and being at BRC as well. And she initially worked in the area of experimental high pressure physics. Yeah, there she through the paper, I understand that she uncovered a novel phenomena where when a material is subjected to high pressure, it actually becomes amorphous. It usually can turn crystalline, but it turned amorphous. And this particular work seems to have gathered wider recognition, and she was awarded an Young Scientist Award for this work. And during that time, she got married as well. So she moved to Bangalore, where her husband worked, and BRC stationed her at the Seismological Center at Gauribidnur. And during that time, the scientists at Gauribidnur had an office at RRI. So that's how Hema's connection at RRI began. And in 1995, she was offered a faculty position at RRI by the then director to actually start an optics group, which was not there till then. So I was just doing my PhD when Hema joined, final year of my PhD when Hema joined RRI, and I submitted a year after that. And when I was applying for postdoc, Professor Kumar came and asked me, there is this upcoming optics lab. Would you like to come and help Hema start an experiment? Because Professor Kumar strongly believed that there should be an ongoing experiment. The science should be there all the time while you're doing other stuff as well, which I think something which we all inculcated in the course of our overlap with him. So this is one of the first experiment myself and Hema did at RRI. When I met her first, as I was recalling yesterday, when I met her first, I realized that this was a driven, ambitious person with a rare dose of personal warmth as well. There's always this, she always cared about you beyond, the actual thing which she is engaging you with, which actually is very endearing. So, so this was one of the first experiments we did, and coming from theory PhD, I got the maximum fun out of doing this experiment, I can say now. So the goal of the experiment was to image an opaque object inside a turbid medium. So when you try to, typically a turbid medium by definition has many scatterers in it for the light to scatter. And so the light typically takes a diffusive path inside the medium. So in a diffusive scattering regime, what happens is very soon after the first few scattering, the photon loses its memory of the incident polarization and its direction of propagation. It just gets randomized. And so it won't carry the shadow of the opaque object which was kept inside the medium. And people already were trying to do this imaging of, diffuse objects kept inside a turbid medium. And one of the things which they did was to catch these so-called ballistic and snake photons. So what are they? So in the presence of many scatterings and many scatterers, there exists non-vanishing number of paths, which are the so-called ballistic and snake paths. The ballistic paths are those paths those very few paths, exponentially small number of paths, wherein an incident photon doesn't get scattered at all, despite the existence of many, many scatterers. The take-home message is that such scattering paths do exist, yeah? And more numerous than the ballistic path is the so-called snake paths, wherein the photon does scatter, but it suffers fewer scattering. So what people did prior to Hema doing this experiment is that people time-gated to get this opaque image of the object. By time-gating, they synchronized the source and the detector in such a manner with a suitable delay depending on the length of the object which you're trying to image, which is inside this turbid media. So such that your shutter will be open to the detector only for a very short time. The shorter the time is, the greater the probability it will catch this ballistic and snake photons, because those would arrive first, because they are not getting scattered. They are not suffering many scatterings. So time gating was the preferred method. And thereafter, people already had done, apart from us trying to do this experiment, people had already done also what is spatial filtering, So the original direction of photons are those which preserve the direction, which would be the ballistic constraint photons, and those can be filtered out by having a spatial aperture at the appropriate distance from an imaging optics. So this was also something which already existed. So what Hema's original idea was, she said, let's do the time gating, and the time gating was complicated to deploy, in the field, so to say, because you need to carry the electronics for the shutters, for the fast shutters, and the faster the shutter is, the costlier the equipment was, and so on and so forth. So she said, let's do the time gating, but not in the temporal domain, but not in the time domain, but in the frequency domain. Yeah. So this was her idea. So so we did manage to put a timestamp on the incident photon, and the timestamp was putting rotating, changing one of the variables of the light, in this case the polarization variable, in time by having a rotating polarizer, and looking in the image plane, in the CCD plane, at each pixel at the appropriate Fourier component. So you collect large number of data, come home and load it on the computer and do the Fourier transform and look at the pixel image or value at that appropriate Fourier transform frequency. Of course, there is a suitable analyzer on the other end, which discriminated the polarized light from the unpolarized background, which the scattered photon, which give. So after many trials, we managed to find the appropriate time about which we have to take the data, and the intensity and the aperture size and so on and so forth. And we're very happy to see, for example, here A, B, and C and D are, this A shows the image, bare image, without anything on the CCD camera, without doing anything. Just put a CCD, look at it. How does it look? It looks nothing. Nothing, no image comes. And then in image B is the DC image, that is the zeroth order Fourier component. So it'll give the light which just managed to either specular reflection or stuff which are coming from other things other than the turbid media. And image C is the one which actually is at the right Fourier component, and image D is the one without the turbid media. So this was an IC leg. If you have seen an IC, this was just an IC which was put inside, and this was an IC leg. So we were very happy doing this experiment, and it got published as well. And so that started Hema's association with light scattering in random media. I would say this was something which she always wanted to do and did in some form or the other till very late in her life. So one of the other things which Hema's group did, which I was not involved in, but which attracted wider national and international attention, is this finding out what kind of intensity statistics does a light which travels through something called a random amplifying medium exhibit. Yeah, a random amplifying medium is not an amplifying medium where the amplification scatterers are situated randomly, positionally, and but each of the scatterers not only scatter the light, it also amplifies the light. Yeah. So along with every amplification, the fluctuations associated also amplifies more typically, because these are random amplifying medium. And so the question that was asked in this publication, which I think Hema did with her student along with Professor N. Kumar, is the fact that what kind of the intensity fluctuations do these statistics of light coming out of such random amplifying medium show? And they found that contrary to usual expectation, it should be Gaussian statistics due to the underlying nature of a large number of scattering events present in such dense media. It was for appropriate concentration of the scatterers and appropriate gain parameters. It was showing a Levy statistic. Levy statistic you can imagine as a Gaussian with a fat tail on one end. Yeah. So all of us who were intensely talking about this experiment at that time in RRI, things where people talked about their experiments animatedly, and so a lot of discussion happened even with people who are not directly involved in the experiments. So we and Professor Kumar used to call it as larger than rare paths. So again, this one of the rare paths is what contributes, but the rare path is exponentially rare, but then it has a exponentially larger gain. It also so the rarity of the path and the largeness of the gain is what gave rise to the Levy statistics. And I think the larger community, as well as HEMA students themselves, along with HEMA and Professor Kumar, benefited immensely from this experiment. And we all learned, for the first time, we learned statistical optics in an experimental setting, I must say that. So thereafter, I went for a postdoc and then came back. And then HEMA by then was well into procuring experimental apparatus for starting laser cooling of atoms at RRI, which Professor Kumar wanted to do. And so prior to actually doing the experiment, we also got into reading material about Bose-Einstein condensation, and it actually resulted in a paper where me and HEMA jointly published this paper, which I won't go into details, but just to say that we were also side by side trying to understand as much theory about this as possible, and trying to start the experiment as well. I joined the faculty at RRI in 2001, and just to tell you how naive we were when we started the experiment. We were building external cavity diode lasers, and the laser which was deployed to get our first magneto-optically trapped cold atoms was home built. So the previous day when we saw before we saw the mod, our so-called repumper home built laser broke down, and HEMA actually stayed back and put the laser diode back and got the fluorescence and so on. So I would say that it was a period of high enthusiasm and blind optimism, which I think as years goes by, we also grow jaded, but this is a very important ingredient for doing good science, is what retrospectively I would imagine that it's true. So a lot of enthusiasm, and we can do anything optimism, and of course driven by such stalwarts like Professor Kumar and Professor R. Srinivasan. So this is a team which managed to get the first mod at RRI way back in October 2001. And almost all of you will recognize all the figures to present, just for completeness. This is Meena, who was our technical support at that time. I think any number of vacuum experiments, vacuum setups or arrangements were broken and remade with the help of Meena. And this is me, and this is Professor Kumar. This is Professor R. Srinivasan, and this is Chandrasekhar, who's now a faculty at IMC Chennai, and he was a project student before he got his Rhodes Scholarship. And this is Professor Hema herself. So, and after getting the mod, it was boost in the arm, so to say. So we went on to do spectroscopic measurements with cold atoms, and I think it was a high period of doing cold atom experiments for me, at least at RRI. So Hema then thereafter dwelled into what kind of experiments one should do if at all we managed to achieve Bose-Einstein condensation. And one of the things she came up with, again, it was her original idea. So to find out, I mean, when let's say you have you shine laser, and in some with some manipulation of laser parameters interacting with the atom, it's possible to make laser-induced collisions of the atom. So when two atoms come very close to each other, the individual energy levels will also change. And then imagine that let's say you have a laser light which is not resonant with, let's say, two kind of atoms which are present, let's say one rubidium and one cesium atom. But then when these atoms come together, for appropriate frequencies of the laser, which is not resonant with either of the atoms when they are far away, now they can absorb two of these photons and go to their respective resonant energy levels. Yeah, resonance as described when they are far away. Yeah? So this was before boring you. I mean, I don't want to bore you with details. This is what is called non-resonant absorption of photon pairs. Just on one line, this is collective absorption of more than one atom of a non-resonant light, a pair of photons in this case. And so that each of the atoms can go to their individual excited states. Yeah. So this idea already existed, and Hema made use of this idea to come up with the quantum logical gate operation, which is a universal gate as well, which is a CNOT gate, and it was published. And in this paper, apart from me, Hema, and Professor R. Srinivasan, Anders Kasberg, whom many of us know here, who was a visiting professor at RRI some years back. He was also involved in this work. So just to tell you that our interests were not only in getting the MOT experiment and all. It was also into proposing ideas for in the cold atom setup. And then, of course, it was natural to talk about quantum walks with cold atoms. And this particular paper, which she did with her student, came out with a proposal wherein you can find out quantum walks in, again, cold atoms and optical lattice by not looking at positional displacements of positional displacement, but looking at internal energy states. Yeah. So this was also, again, one thing which started Hema's foray into quantum walks. And she also did another experiment just with light and with no atoms. This is, establishing quantum walks in frequency domain using what are called acoustoptic modulators and Michelson interferometers. Yeah. So using these two arrangements, she managed to reproduce a quantum walk in frequency domain, even though with a classical light, and then went on to show that even if you deploy a single photon source, the results would be exactly the same. Yeah. So this was done again with one of our later graduate students, Deepak. Right. So Hema, as we all know, did a lot of other things other than these particular experiments, which of course a lot of time goes on in doing an experiment, getting a publishable result out. So she, during her later years, she wanted to do a brain-computer interface research at RRI, and she started this activity. And several of EEG members were involved in it. She was also collaborating with hospitals like Aster Hospital in Bangalore, where she would get data. And I was not involved in this, so I cannot go and tell you what exactly she did here. And she also had active collaboration with scientists at TIFR, Mumbai. And one of the things which they did, which caught all of our attention, was to how, a photothermally created bubble, air bubble, how it cavitates and what is the kind of light emitted from such bubbles. And so that was also one of the interesting experiments, which I think got published in, I forget now which journal. So as I said before, prior to coming to RRI, she was conducting seismological data. And I distinctly remember there was just one computer center at RRI, and I was just writing my thesis. So all of us would stay back late at night, well beyond we would go at 2 a.m. or something like that. And Hema, during most of these days, would stay till 9 p.m. and would be analyzing reams of seismological data. And amidst our, we'd be shouting, screaming, like all graduate students do of that age, I guess. So, but she would be stoically sitting there and analyzing a lot of seismological data. So I still remember that when she's around, we used to be less noisy. Yeah. So last but not the least, she was also in the planning team, which recommended and procured a very large funding for quantum technological initiatives in India, which got approved by the cabinet, I think just last year. Yeah, Hema was headed the optics lab and the LAMP group for several years, and then she also was the head of research facilities at RRI, a position which she held for half a decade, and which oversaw many of the workshop and electrical related works at RRI. So this was a photo taken there. So as a person, I think all of us who interact with her know that she had a very fine sense of aesthetics. Some of the paintings she had in her office is something which would tell of her taste in fine paintings, at least. So and she carried herself with, of course, grace and dignity, and she's a strong feminist. And even though she wouldn't be very vocal about it, in every action she did, right from taking a decision or even moving a heavy chair. She wouldn't call anyone. She would try and lift the chair by herself. So she was a very strong feminist, and she lived it in. She actually very independent, and most of her everyday tasks never rely. I mean, if possible, never relied on other people to do everyday chores. I think that really is something which I sometimes later feel that if I hadn't known Hema, I wouldn't have known that it's possible to do so many things by one person. Like she managed to build labs from scratch. She did just not once but twice. Yeah. So even in later years when she was besieged by illness, she would actually crack jokes and say that wry sense of humor and say it's a tragic situation, but she would see the dark humor behind it, one should say. Yeah. And of course, her students loved her, especially the earlier students, because she would actually spend a lot of time in the lab. All of us who managed to get the mark or did later experiments would just say she'll be there for problem solving and for anything, even just for moral support, just sitting there. She was always available and very empathetic towards her approach to students. And so her earlier students really loved her. Yeah, so I've been very fortunate to have known such a person, and there has been a lot of take-home personal lessons for me, and also the way one has to believe in oneself and forge ahead despite what other people might say about you being, of the weaker gender. I'm sure nowadays nobody says that, but when we were growing up, this was a common reminder. Yeah. And thank you for the organizers for giving me the opportunity and for the audience to listening to me. Thank you.
Thanks, Andal, for sharing your memories. I mean, many of us share the same memories. We all miss Hema very much. So I think, and we were very fortunate that you agreed to, do this. It's probably midnight right now for you.
It's 10:30. I'm 12 and a half hours behind you. So, I mean, it's not midnight. It's going to be 10:30 p.m., 10:30 p.m. Yeah.
Okay, thanks. Yeah. So any quick question? You told us everything. There's really nothing much to ask. So thank you very much, Andal. Good night.
Yeah, lovely seeing you all. Yeah, thank you.
Yes. Bye. Yes. Lovely seeing you.
Bye-bye.
Okay. So we have to open the next talk. So our next speaker is our very own Supurna, who will tell us about her mother, Purnima Sinha. So Purnima Sinha was the first PhD physics student, first female PhD student in India, who worked under Professor Shotendranath Bose. And as you will see, they share the same smile. So she will tell us about her mother, and she'll also tell us how her mother shaped her own career as a scientist and as a person. So we can disconnect from Zoom.
Am I audible? Yeah. Okay, I would like to thank Ranjini for inviting me to speak at this forum on the International Women's Day. So the topic of my talk today is Life of a Scientist, Purnima Sinha. So Purnima Sinha was one of the pioneering Indian women scientists from the pre-independence era. There have been quite a few trailblazers prior to her. For instance, Anna Mani, who was here at RRI, and Prajwal is going to talk about her. There was Bibha Chaudhuri, who was a pioneering cosmic ray physicist who had done outstanding work in the domain of physics of mesons. And Ashima Chatterjee, the distinguished chemist, who was the first Indian woman to get a doctorate in science from an Indian university. But I just wanted to say that I would like to restrict my canvas to Purnima Sinha, because I happen to know more about her life and work than these other pioneers, as she was my mother. So here is a book that is available at the Ramani Research Institute Library on Purnima Sinha, written by Rajinder Singh and Suprakash Rai. It's called Clay, Craft, Music and Science, Purnima Sinha's Life. From the title, it is obvious that Purnima Sinha was not an average scientist, in the sense that she was as much of a scientist as an artist, and these two identities were interwoven through the first word that is of the title, clay. Clay played a common thread in her life. So this is just to give a sense of the timeline of Purnima Sinha's life. She was born in 1927 in Calcutta. On the year of independence, 1947, she got her BSc in physics from Scottish Church College, Calcutta University. It's interesting to note that at that time, Presidency College didn't allow women students. In 1950, she got her MSc in physics from Calcutta University. She was the only woman in a class of 60. Then subsequently, between 1951 and 1955, she did her PhD research in Science College under Professor S.N. Bose of Bose-Einstein statistics fame. In 1956, she got her formal PhD degree from Calcutta University, being the first woman to be awarded a doctorate in physics from Calcutta University. On the same year, she married Surajit Sinha, an anthropologist. Actually, he was a true intellectual partner. And subsequently, she worked at the Geological Survey of India in Calcutta, then at the Biophysics Lab at Stanford University, then at the Bose Institute, Calcutta, and for the longest period of her life, she had spent at CGCRI, the Central Glass and Ceramic Research Institute, from where she retired, and she passed away in Bangalore in 2015. So here is an outline of my talk. So I'll first give the family background of Purnima Sinha, then talk about her PhD work and how clay served as a common thread in her scientific and artistic creative pursuits. Then talk about her contribution to science outreach, then a brief analysis of the enabling factors in her life, and talk briefly about her influence on me and my choice of physics as a career and beyond, and conclude with a few remarks. So let's start with the family background. Purnima Sinha's life was significantly influenced by her extremely progressive-minded father, Naresh Sengupta, a distinguished legal scholar and a writer who had a deep commitment to women's education. So here is a picture of Naresh Sengupta. He was a doctorate of law. Purnima Sinha would have turned 95 this year. She was the youngest child. Her sisters, all of them were older than her, were accomplished in their fields, economics, chemistry, and mathematics. Purnima was the first woman PhD in physics from Calcutta University in 1956. Her sister Sushama, who was 24 years older than her, born in 1903, was the first woman to receive a master's degree in economics from Calcutta University, and sister Punima, born in 1913, was the first woman to receive a master's degree with thesis in chemistry from Calcutta University. So here is sort of a collage of Purnima Sinha's PhD work, which she received her PhD in 1956. Here is a picture of this one is the front page of her PhD thesis, X-ray and differential thermal analysis of Indian clays, which was submitted in November 1955, and she received her PhD in 1956. Just to give a perspective on her PhD work, Watson and Crick discovered the double helical structure of DNA using Rosalind Franklin's X-ray diffraction photograph in 1953. Raymond Gosling, a PhD student, had collaborated with Franklin in this matter. And as we all know that it's an iconic discovery in the history of physics, not just of physics, of history of science. This was during the period Purnima Sinha was working on her thesis project on X-ray analysis of clays in Calcutta. So here are a couple of images from her thesis. One of them is a set of X-ray diffraction photographs of Indian clay samples collected from different parts of India. One of them is from, for instance, from Santal Parganas. And another one picture is a set of curves of differential thermal analysis curves of Indian clays. So her approach was the following. Her goal was to get an understanding of the structure of Indian clays samples from a comprehensive point of view. A combination of X-ray crystallography, differential thermal analysis, and chemical analysis. I must mention that in the process of doing her chemical analysis, she used to interact with Ashima Chatterjee, the distinguished chemist who was her senior. She did her PhD work under the guidance of the well-known physicist, Professor S.N. Bose, of Bose-Einstein statistics fame. Her PhD work was on X-ray crystallography of clay minerals. One of the remarkable aspects of her PhD was the building of the X-ray instrument from scratch using material from the World War II surplus gathered from the streets of Calcutta, now Kolkata. She received a scholarship from the Assam Oil Company during her PhD, which is of historical significance. It's an example of connection between basic science research and industry. She published her research work in the leading journal, Nature. Here is a snapshot from one of her papers in Nature, appearance of exothermic peak in the differential thermal curves of vermiculite. So as I had mentioned, clay was a common thread in her creative pursuits, both in science and art. Her PhD work was in the area of clay minerals, which was also the focus of her lifelong research at CGCRI. She had done work on the origin of life at Stanford, at the biophysics lab, and the point of view was that clay is a substrate for the origin of life. This dates back to Bernal's idea, and she pursued this line of inquiry. She was also a highly talented and skilled artist who had worked with clay extensively. This is one of her numerous artworks made out of clay, fired clay. This doesn't do justice to the scale of the work. This is about 6 feet by 2 feet. It's a mural which still continues to be there on the wall of a house in Shantiniketan. Now let's come to her contribution to science outreach. She had a deep commitment to science outreach and had written many popular articles and books in Bengali. The inspiration came from her mentor, S.N. Bose, who had a deep commitment in this regard. She was awarded the Gyanobigyan Puroshkar for science popularization in Bengali. This is a picture of the Gyanobigyan Puroshkar. Some of her books here in Bengali, Bigyan Sadhana Dharaye Satyendranath Bose, which is a Bengali biography written for the popular audience in Bengal, and Mono Jorobostu, which is a Bengali translation of Schrodinger's Mind and Matter. So just to give a brief analysis of the enabling factors in her life. There were a number of factors which enabled Purnima Sinha to achieve her creative goals. An enabling family atmosphere, a very supportive and encouraging father. Her mother, Labanya Prabha, was also very supportive of her academic pursuits. A very empathetic and supportive PhD guide who was refreshingly free from any gender bias. This is S.N. Bose. An anthropologist life partner who was her intellectual companion and had been a source of encouragement. her influence on me, she has been a major influence in my life, shaping my interest in scientific research and science outreach. We have written a collaborative popular science article in Bengali for Gyano Bigyan, and have also collaborated on cover designs. My mother and I have done that. I have enjoyed discussing DNA elasticity with her, a topic on which I have done research, and she has also had interest because of her background in biophysics. I had given her a book, Unraveling DNA, the Most Important Molecule of Life by Kamenetsky, to read, which she promptly started translating into Bengali, which indeed was a daring project to take up, given her failing eyesight in her later years. And it also contained a number of very state-of-the-art molecular biology terms, which first of all, she had to understand those terms and also translate it into Bengali. It was a really challenging job, and she did it. Both her daughters, Sukanya Sinha, ISI Bangalore, and Purnima Sinha at RRI Bangalore, have chosen physics as their research focus, thanks to Purnima Sinha's enthusiasm for the subject. Here is a collage of a few images from her life. The top two pictures sort of capture her scientific life and her artistic life. So the picture on the left is an iconic one where Purnima Sinha is seen standing between Paul Dirac and S.N. Bose, the creators of the two fundamental statistics of identical particles in quantum mechanics. On the right is a picture of Purnima Sinha playing the tabla. This is also another place where she has crossed boundaries. She has entered a male domain with complete ease. She was often not even aware that she was a woman who was playing the tabla, and it was quite amazing. She learnt it from the great tabla guru, Gyan Prakash Ghosh. And the bottom layer are 3 cover designs made by her. Actually, the first one, Tribes and Indian Civilization, is a book written by her husband, Surajit Sinha, and this was a collaborative work with my mother. My mother and I jointly did the cover design. And the second one is Bigyan Sadhana Dharai Satyendranath Bose, which is a Bengali biography of Bose. And the third one is an amazingly detailed and analytical study called An Approach to the Study of Indian Music, where she had analyzed folk and tribal music from Barabhum, Purulia, where my father had done anthropological research. And she noticed that the folk music acts as a substrate for the Indian classical tradition. And this was a rigorous analysis, which reflected her scientific mind also. So just to conclude, Purnima Sinha was the first woman PhD in physics from Calcutta University. From the records, it appears that she was perhaps the first woman PhD in physics from an Indian university. She was fortunate to have grown up in an encouraging and enabling environment. She was involved in multiple pursuits: experimental physics, science popularization in Bengali, writing on science and society, fine arts, and music. This is indeed a crucial aspect that contributes towards a woman scientist's ability to achieve her creative goals. She had also served as a role model for her 2 daughters, both of them, Sukanya Sinha, ISI Bangalore, and Purnima Sinha, RRI Bangalore, are physicists. Now, I'm just going to end here. This is a picture that is very dear to me. This is my mother with a group of tribal children. And around the end of her life, she and her husband started an informal school called Melameshar Pathshala for the tribal children. And this also reflects something very special about her. Just professional achievement was not that satisfied her. She had a deep commitment to society. She felt the need to give something back to the society, and this photograph sort of captures that. And here are 3 links where you can read more about her. Lilavati's Daughters, there's an article by her. And there's a very nice article by Madhuri Katti in Life History India, Purnima Sinha, pioneering physicist, and the book Clay, Craft, Music and Science. That book is available here at RRI, in the RRI library. If you're interested, you can read it. Thank you for your attention. Hi, yeah. Yeah, yeah.
These enablers, of course, were very valuable to her, as they are to very many women scientists who succeed or are able to practice science, come to the point where they can practice science in freedom. But I wanted to also ask you the question about what were the things that she were not enablers.
Obstacles. Yeah.
Obstacles.
Right.
What were the things that you remember
Yeah.
that were obstacles in her time, which you perhaps can find similarities with, that those obstacles still remain today? Or were there some things that were just historically there and may have improved over time?
Yeah. For one of the things, for instance, like child care, the awareness that child care facilities are a necessity, that awareness has become much better now. So she had to, the arrangements she had to make to take care of us while she was working were much harder at that time. I think that would be one of the things that I remember. I think, at least, only in recent times that you see creches connected to institutes, and that's one of the things that I would say is, yeah. I want to mention that
Yes,
Ashima
please.
Chatterjee is actually related to Ranjini.
Yeah, my grandmother, yeah. Yeah, okay. So, so that was really very inspiring and very interesting. So now from clays, we move to galaxies and outer space. And Gunjan here, who's working with Nayantara, will give us a popular talk called Bullets from Space.
Hello, yeah, I'm audible, right? Yeah. So thank you. So I'm Gunjan. I'm a PhD student here at RRI, and I'm working in Department of Astronomy and Astrophysics. So I'll be talking about, thank you. So I'll be talking about one of the greatest mysteries that surrounds us all the time, and even now. So we are being bombarded by bullets, which we call cosmic rays, being pelted at Earth at energies greater than an exploding nuclear bomb. And so thankfully for us, we are surrounded by Earth's atmosphere. We are protected by the Earth's atmosphere. And before I tell you how the atmosphere acts as a hero, I'll just try to explain what cosmic rays are. By rays, we typically think of a photon or a ray of light. But cosmic rays are in fact particles, like charged particles like protons or helium nuclei, or in fact heavier nuclei, carbon, silicon, iron. So coming back to the atmosphere, when this charged particle enters the Earth's atmosphere, it interacts with the molecules in the atmosphere and breaks down into smaller particles. And we call these particles as daughter particles or the secondary cosmic rays. And these secondary cosmic rays interact with more particles in the atmosphere and create further smaller particles with even lesser energies. And this goes on, eventually giving us an extensive shower of particles just raining down on the Earth. And this air shower, so this is a hypothetical picture of what this air shower looks like. And this contains a lot of information. Like scientists actually use this air shower to determine the mass of that primary particle that started it, or even the energy of that particle. So how did it all start? So when radioactivity was first discovered, scientists believed that only the radiation that is coming from the radioactive element in the surface could ionize the air particles, could ionize the atoms in the air. That is like stripping off the atoms in the air of their electrons. So to test this theory, Theodore Wolff in 1909 performed an experiment using electroscope. On the ground, he of course measures the ionization rate, and then he moves this electroscope to Eiffel Tower. And you would expect that when you go high up from the ground, that ionization rate decreases. But what he instead noticed is that the ionization rate decreases, but not with a significant amount, or the amount that he had anticipated. So then, in the later years, Victor Hess took it to another level. He took several hot air balloon flights with several electroscopes in the hot air balloon till 1912. So he took he took it to the heights of like 50,000 kilometers in the atmosphere. And the commercial planes that fly is at the heights of 100,000 kilometers, just for reference. So what he noticed at such height was that the ionization rate had started increasing. So to rule out that these ionization radiation was coming from, say, sun, he took these flights even at night and also during the solar eclipse. But not much difference was noticed. So he concluded that this radiation is coming from, is not coming from the terrestrial origin, but somewhere from the extraterrestrial origin, and thus the term cosmic. And he got a Nobel Prize in 1936 for this discovery. So later scientists followed this discovery and built detectors to detect these radiation. So in year 1991, we actually detected the first highest energy cosmic ray particle with an energy of 3.2 into 10 raised to the power 20 electron volts. So electron volts is the unit of energy we use for cosmic rays. And this particle was termed as "oh my God" particle. So to give you an idea of how huge this energy is, if this is the energy a tennis ball would have if it was hit by all the might of a professional tennis player. So now just imagine all that energy squeezed into just one tiny atom. And a tennis ball might have, say, 10 raised to the power 20 of such atoms. And if that does not impress you, think of the Large Hadron Collider, which is like most powerful man-made accelerator that exists on Earth. So it can accelerate particles to energies up to 10 raised to the power 13 eV, which is still 10 million times smaller than the energy that this particle had. So what actually put this energy in this particle? So after this, more rigorous Experiments were done, several detectors were built, and extensive techniques were used to detect more of these particles to understand where are these cosmic guns and what are these cosmic guns firing these bullets at us. So it seems as if, since we still don't know what are these cosmic guns, it feels as if we have not progressed much. Nothing much has changed since then. But a lot has changed. We have more data than ever now. And the plot on the right shows you the flux that we have of cosmic rays now. So on y-axis, we have the flux, or say the number of these particles with respect to energy on the x-axis. So mathematically, this data can be defined by a power law, and you'll notice a few features here and there. And you could also think of this data as a human leg with a knee and an ankle, signifying the features that we see in this curve. So as we can see, a vast majority of these particles lie at the lowest energies. And these are believed to be coming from the extreme events happening on or in the surface of the sun. Then as we move to higher energy, we have high energy cosmic rays, or very high energy cosmic rays, which we believe are coming from the events, explosive events, or high energy events happening in our own galaxy, that is Milky Way. And somewhere around here, maybe the ankle or before the ankle, we expect a transition from galactic cosmic rays, that are the cosmic rays that are produced in our own galaxy, to extragalactic cosmic rays. That are the cosmic rays produced coming to us from outside our galaxy. And it is simply because as we increase the energy of these particles, it becomes harder to confine them in a small space, and small space being our galaxy here. So like I mentioned, that there are 100 of these particles just being bombarded at us. But we really need to take into account the area at which these particles are falling. So for example, at the lowest energy, the rate of these particles would be 1 particle per meter square per second. And as we go on, as we go up in the energies, we see a lot lesser flux of these particles. So around the energies that we can obtain from, say, Large Hadron Collider, we expect 1 particle per meter square per year. And going up higher in the energies, we expect 1 particle per kilometer square per year. And if we think of the energies that oh my god particle had, we expect that particle like this would hit Earth at the rate of 1 per kilometer square in 1,000 years. So that leaves us with limited data at the highest energy. So what we do to get any information on the source? We know we have two things that we can make use of at our hands, which are the magnetic field, and which exist almost everywhere. So when a particle starts from the source and tries to reach to the Earth, it will interact with this magnetic field and get deflected, and will lose the information from where it comes from. But at higher energies, this might just help us, because at higher energies, particles are deflected lesser by the magnetic field, and thus limiting the region from which it could come from. The other thing, for us, the universe might just look quite from a source to Earth, but there are photons that is filling the entire space in between. And these photons, for a charged particle, would act as a traffic or a crowded bus stand. So particle would interact with these photons and lose energy. So if it started with energy, say 10 raised to power 21 eV, it will interact with the photons, lose its energy, and can only, and say it loses its energy, and we detect it at 10 raised to power 19 eV. So it sets a limit on the distance from which it can travel to us without losing much of its energy. And that tells us how far the source can be. Along with this, we cannot just figure out what the source is on just relying on cosmic rays. We need more messengers that point out to the source of these particles. Since the cosmic rays here, shown by red, they'll deflect in the magnetic field, they will lose the information on the direction of the source. So we can consider neutrinos as the other messenger particle that might give us any information about the source of this particle. So neutrinos are chargeless particles that are produced when these cosmic rays, or the hadrons that we believe them to be, interact with the protons or the field around the source. So we expect neutrinos are produced, and it can come to Earth without deflecting much, and thus like acting as a smoking gun and like pointing to the source from which it comes from. Another messenger that we can use to fix this puzzle is gamma rays, which are again produced when the cosmic rays interact with the particles at the source. And again, since these gamma rays are also not deflected by the magnetic field, we can see them, we can receive them at Earth and try to constrain the area, the sources that these particles come from. So now we have actually a lot of potential sources that could be producing these high energy bullets, but the puzzle is still not complete. So we need several messengers, more data to solve this. So that's all. Thank you.
Thanks a lot. So, any questions for Gunjan?
Just some small correction about the confusion with the heights, altitudes. With, the commercial planes are flying at 10 kilometers.
10 kilometers?
Not 100,000 kilometers.
Okay, I might have read it.
Yeah, and hot air balloons, well, the record was 21 kilometers, but usually they also fly around below 10. Especially in 1912. So I think it meant, you meant 5 kilometers, not 50,000. You must have thought 5 kilometers.
Yeah, I'll check that.
Thank you. Are there any questions? Thanks, Gunjan, for a very nice talk. So our next speaker is Sonali Sachdeva from Astronomy and Astrophysics. So Sonali works on the formation and evolution of galaxies. She did her PhD in Ayuka, and she's now a postdoc here. And she's going to tell us about how she got here. And it's very poetically called My Journey Through Space and Time.
Okay, so I'm going to tell about my journey through space and time. We all definitely think that our lives are extraordinary because we have lived through it. But today I will tell you as a statistic when I am just a dot and then what is the overall picture that I have observed. So these are, so as the disclaimer is, these are personal experiences, personal observations and understanding. So I might have been very naive and you can say that, oh, she missed the main thing here. So that's my main thing, that this is all personal. This is my understanding of what is the situation in terms of women, in terms of, and I'll tell you through the various institutes I've been to, starting from my bachelor's. So it has been nearly 18 years, starting from 2004. So I hope you enjoy the journey with me. So I've been fortunate enough to be at one of the best institutes in India. My bachelor's is from Sri Venkateshwara College. It is one of the best colleges in Delhi University. So there are very well-equipped labs, very amazing lecturers, and a sports ground, all kinds of facilities. And it was really a very nice experience, beautiful experience. Now, in terms of the topic, so you see, in that kind of a microcosm, in that kind of, nobody will think of emancipating women more because it is a woman's world. You can see that women women are leaders, they are the organizers, there were events, and most of the big decisions were taken in, this is physics, and there were, so women were the force with which we were all aligning to. I was also one of the organizers, and so there you don't feel that there's any lack of equality. As per the All India Survey of Higher Education, so I was going through it during this talk, and so some 3 crore students at this moment post 12th are doing some kind of bachelor's, and BSc is basically 50 lakh, and 52% are female. So it will be more in zoology, botany, it will be lesser in some other subjects. For example, BTech and BE would have a lesser percentage, but overall it's not bad. It's quite good. It's 52%, and if you are going for, if you just focus on the honors one, then there's 7 lakh students, and 45% are female. And then yes, of course, you would not see that, okay, that yeah, I have said that. So yeah, and of course the lecturers' percentage is also very good. So you see them at all levels, and you see them succeeding, and quite it's quite an equitable atmosphere. Then my master's was from St. Stephen's, so you use the library and all the facilities there, and then most of the classes are in the Department of Physics and Astrophysics. So so, and yes, again, brilliant infrastructure. All our labs, all our lecture halls were AC. You will understand if you are from Delhi. Then very nice lecturers, everything, there was nothing which I would say was lacking or not at par. And what about women? So here you get a very nice glimpse of how we live in two Indias, which seem to be quite disconnected, and then where do they connect? And so there are these women who are traditional, who may not be that confident, but okay, and then there are these women who are, so there are introverts, there are extroverts, they are traditional, they are modern, they are submissive, they are assertive, they are accepting, they are revolting. You see a very nice mix. But I would not say that, the girls from the rural background or from small towns were all the introvert types. They were also assertive types, and not that all the urban ones were very assertive types. Sometimes they were just being too traditional in their mindset or in their choices. So in that also there's a very nice mix. But you see that mix. You see that how people are coming from different backgrounds. They are either letting those backgrounds push their choices, or they are making their own choices, how courageous they are, so all those kind of things. It's a very nice mixture, basically. So then one more important thing is that it has nothing to do with the talent, the inherent ability, the skill, of your interest in that subject. So you could be succeeding and you could be not succeeding, and that has nothing to do with the other things. Then, but where these things come into picture is in terms of, do they bound you in terms of which opportunities you will pursue, and which choices you will make, which kind of, for example, in masters, when you come to the second year, then you have to make choices regarding the subjects. So it was so clear to me that, oh, astrophysics, my God, you can really learn about galaxies and stars and sun and planets, and somebody is going to teach you that. So I thought, like, that is like the dream come true, and I thought that would be the most taken up subject. But GTR and General Theory of Relativity and Cosmology were the least taken subjects, and astrophysics. They were least taken because people were like that we would not be able to, we may not have more career choices after that. And so there are many things that govern. So, but it's not it's not talent. It has nothing to do, it has, and is the interest the governing thing? That also depends on how much societal pressure and those things you face. Then I've done a very interesting and one of the most beautiful things. It was just a 1-year course. I had got, when I gave NET JRF, I got NET, I didn't get JRF. So I had 1 year and I did bachelor's in education from Central Institute of Education. So then I got JRF and then I started PhD. But this has been, why this was a very nice experience is because they get students from all streams, from history, from social sciences, from psychology, from everywhere. So, and then those people are generally the most outspoken and opinionated, because there are 2 interviews that you pass other than so there are 30,000-40,000 students who sit for the exam and only 200 make it. So overall, so they are all those, and then when suppose there's a topic of discussion, and then the teacher would try to get each one's view. So it's so interesting that they have all come from very different understanding of things, and then when they give their view, it's a huge variety, and it just enriches the way you look at society, and you understand that there are so many perspectives, there are so many ways in which people think, in which people decide things, etc. So this is also a very woman-dominated place, and why some women have come for this. It could be a preferred choice. It could be that they love teaching, but it was also that then people don't want to pursue such a large academic career. They would just want to get out of it, get a job, get married. Then there are traveling constraints. I want to do research, but I can't apply to so many institutes. There are so many women who do not apply even outside their state, and that is sometimes forced by their parents, and sometimes they also internalize it, that how will I survive by myself, and security constraints and concerns and stuff like that. So then, some are preparing for the competitive exam to get some job, and what governs your academic career, other than your interest, is also a lot of how you view your place in society, and other personal fulfillments that you seek. So then after getting JRF, I was back to PhD, and so first let me just share these iShare statistics. So PhD in science at this moment, or during 2019 to 20, they found that 50,000 people were pursuing PhD in science, and 45% were female. And physics is done by 7.5 thousand, and 40% are female. This is not a bad ratio, and if you go for zoology again, this will become some, instead of 40%, it will become 75%. So, but it doesn't give you the correct picture, because if you go for institutes of national importance, if you go for a little bit higher institute, a little bit more known institutes, then it falls considerably. So why have women not opted for, or not even sometimes appeared for exams that take you elsewhere for PhDs? Because they are given this constraint, okay, do PhD, but locally, do it within, from Delhi, do it from, but don't go here, don't go there. So local opportunities, and then they, suppose they don't want to teach in a school, they would much rather like to be a lecturer. So then they might be again preparing for exams and other kinds of jobs. And then of course so this I've seen a very big difference in university students and institute students. University students are not looking for postdoc. Maybe one or two that they don't even consider it. They feel that, okay, once we do PhD, we'll apply for ad hoc positions, we'll apply for, and then maybe we'll get permanent. But in institute, I think there's also a peer pressure that what is considered to be a successful PhD is, have you got a postdoc abroad? And so even if, so I say that, okay, if you want to do postdoc, that I understand, but there's this, if there's undue pressure that I just don't want to do a postdoc, but I'm supposed to. So that is, so for example, I have known people who tell me that I don't want to be a professor. I am doing it right now, but when I'm 50 and I'm doing the same thing, I don't even want to do that. So that can also, that is also a fair choice. So pressures can exist on both sides, and yeah, and of course, yes. So as you go higher into the academic career, you notice that the family pressures and the societal pressures are supreme in terms of what women are deciding about their next step. Okay. Now I was my first postdoc was at IUCA, and it's a very nice place, Inter-University Center for Astronomy and Astrophysics. It's in Pune. One of the best things about it is it's an inter-university center. So students from all over India, students from Northeast, from Kerala, from Kashmir, I have made so many friends from around the country, and that is because of this place. So here also you can see that how women from different places have different kinds of pressure, different kinds of, and then the numbers have fallen. You can see that, okay, 40% in PhD, and that I'm talking of the past year, when there have been so many improvements in terms of there have been steps taken to ensure more equality. Then for postdoc, and this 25-30%, this is also because some women say that I want to do postdoc, but I can't do it abroad. So this 25-30% is also thanks to that. And then, of course, faculty, I think at my time there was no female faculty out of 20. Now I think there is one. Yeah, so the main thing is that why they are not in the faculty positions is because you have to do postdoc abroad, that you have to do many postdocs, and you have to do postdoc abroad. And that is very difficult when you want to get married, and then you have to take permission from two sets of families, and it is so everyone will agree. You can be lucky, right? So but at least people should acknowledge that luck has also played a factor if they have risen. Not just so that's what I wanted to say, that so there are these girls coming from all over India. I don't think they were lesser in ability than any of the girls who actually moved forward and made their mark. It was also about how much support you get from the family, financial stability also. Like they was like, no, we can't. We have to have a job, and this pressure is there on men also. You know how I was reading how patriarchy hurts men also. They are supposed to earn for the family. They are supposed to go out. Suppose he wants to be a house husband, that is also not allowed. So the main thing that I understood was it was not just perseverance, hard work, aptitude, talent, and skills. It was also courage to go against. If suppose somebody is not supporting you, still take the step, still go ahead, and it's luck. Right. Okay. Then I was postdoctoral fellow at China before Corona happened. So I'm just really lucky. I had such a wonderful experience, and now nobody can go there. Peking University, where Kavli Institute for Astronomy and Astrophysics is one of the tourist spots in China. In fact, people come from all over China to visit that. It's beautiful. There are lakes inside. Anyway, so then there were 15 international postdocs in this institute, which was the highest in terms of Peking University's different departments and institutes. And only 3 were women. This one in India is me, and there were 2 from Korea. This was not just in physics. That's what I was saying, that Kavli was actually having a nicer percentage. For example, when they would require a foreign female postdoc, they would call me, that, oh, we have one. And then there was, there was a global village where people from different departments of Peking University used to stay. So I met women from various countries, and it's not that different. They had similar views, they had similar issues, and they all had made similar sacrifices. I've been to various countries during my PhDs and postdocs. And so there was this one Pakistani postdoc woman, and she was so happy, and she used to tell that my husband has allowed me. So like I have been one of the lucky ones. My husband has allowed me to do a postdoc abroad. Then women who I generally see, they have spouses in the same field, they have spouses at least in the same continents, in the same country, so they are there. But otherwise, and single, there were very few single. Of course, single woman at that age is anyway maybe less. So I was one of the very few in terms of that. Okay, so it's not just academia. Women are missing at the top everywhere. As per Aisha, you can see that lecturer, basically these are colleges, universities, so then it keeps falling. And then also they would not be in institutes of national importance. They might be in lesser known universities. Then all over the world, the things are similar. We have 190 heads of state, only 9 are women. Then if you consider all the parliamentarians around the world, only 13% are women. Then if you consider all the top corporate jobs around the world, 15% are women. And you would say that, relax, wait, things will improve. But numbers have not moved. Numbers sometimes get static, sometimes move downwards since 2000. So numbers haven't seen an improvement. So why is that? The answer does not lie at the workplace, it may lie at home. So you have to do an outside job. You are supposed to do maximum amount of housework also, and child rearing also. So that's 3 responsibilities in a day. And then of course you may choose child rearing to be more important than going out and doing the work. So that reflects in terms of, if you consider senior managers, there was a survey. So 2/3 of men have kids, and only 1/3 of the senior manager who are women have kids. So, and then the another thing that is very interesting is success and likability. So there was this survey in which they just changed the name from a guy's name to a girl's name and give it to two set of students, and they said that, what do you think of this person? What do you, if it was a man, they get acceptance, they get liking, they get appreciation, they get admiration that, wow, this person is so successful. Whereas woman will be seen as like self-obsessed and ambitious and rude and out for herself and political, and so that also governs women's choices. Because why do we want to succeed? We want to succeed for appreciation, we want to succeed because we want acceptance in society. So now if that is anti-correlated, then you would feel that, oh, okay, maybe I should just toe the line. I should just do what society expects me to do, right? Okay, so this is the last slide. I like this this comic strip. This guy is saying, so boys, what's this patriarchy thing all these women are talking about? So yeah, these are my last thoughts. So one thing is that you can't ignore the roads, the society that we live in. So there's this very interesting understanding that men own the roads and women just borrow it. So how men own the roads? They pee on it, they spit on it, they are there, they are just sitting there, they are lying there, they are standing there, just like that. Whereas woman, when she uses the road, she tells that, oh, I'm using it because I want to go from here to there. I'm just borrowing it. I'm not, so you would not see a woman just lingering around, just hanging around, just being there. So these are just, these are all men's spaces, and woman has to tell her purpose and and then she's allowed to be out there. So not just the roads, but the institute, but the kind of places that we create. So, and then another thought is breaking the glass ceiling. Like there was this sportswoman who was taking a penalty shot, and then some editor wrote that, oh, if she takes that penalty shot, she's going to break the glass ceiling. So then the other view is that, why would you say that? Why is this such a extraordinary thing to do? Women do extraordinary things every day, and even if they are just they are housewives, they are still breaking the glass ceiling. Even they are so not just the how would you define that the glass ceiling has been broken? That is that sometimes needs to be challenged. That sometimes needs to be understood in a more wholesome way. Then interest or choice. Some women are really happy just being home, but there should always be a choice. Like so as I was saying, that patriarchy hurts men also. If men want to focus on domestic things, then they should be allowed to do that. And if women want to pursue outside work, there should be hindrances should be reduced. Then the another interesting thought that I found is that why would you think only in this perspective that either you have been a victim of patriarchy, it was all or you were privileged? Why can't we just think outside this framework? And in terms of that, it is that see, who I love is nobody's business. So what my gender is, it should also be nobody's business. So gender can be fluid. So what I associate with, so how does that come into picture, right? So that's just another view. So why would you want to see things in that picture? But because we are in that setup. But we should also be able to think outside that setup to be able to overhauling. If we want to overhaul the system, we first have to be able to think outside it. Then another thing that I found very interesting is when interventions are done, when there are things done to improve the situation. But it should also always be considered that we hope that we are not doing more harm than good. That when woman is given a talk, she says that, oh, maybe because I was a woman. So that kind of like everything is getting done to me because I am from a weaker gender. So those kind of interventions you have to think more deeply, that are they required. So first, if the situation has not been understood properly, it is possible that you would do more harm even when your intentions are like the best. I end here. Thank you.
Thank you, Sonali, for raising some very pertinent points and, doing that so wonderfully and for being so funny. I'm sure there are lots of comments, suggestions, If any solutions, we'll be happy to hear about them.
When you were saying in Kavli, you said there were 15 international postdocs and only 3 were women. What about their own people? What about the Chinese?
Oh, yeah.
They were, what
Yes.
was the percentage there?
Percentage?
Rough.
I think out of 15, there would be like 5, 7,
So
7.
More women.
More, of course, more.
More
More
representation, yeah.
more Chinese women, yes. Yeah.
Thanks for a really, really nice talk. But just the last thing about intervention, it's true that one always thinks, that you're being handed something because you're a woman, right? But as sort of a mildly shameful thing, all I would say is that in the spirit of your talk is that, yes, it's because I'm a woman. That's all I want to say. Because I'm a woman, I get it, and what a great thing it is. Turn it around. We do need interventions, but we have to turn around the attitude to interventions. We do need them. That's all I'm saying.
So, I'll tell you where this confusion stems from another way. Women have reserved seats in metro at various places. So then the question is that if women are saying that we are equal to men, so why do they want those seats to be reserved for them?
Because affirmative action is sometimes needed.
Yeah, I'm not against it. I'm just saying that if you have thought it through, if you are...
I think we don't need to be apologetic about reservations.
No, of course not. Yeah.
So because, yes, it is hard, like you pointed out very eloquently. So,
Prajwal.
yeah, I think...
Prajwal.
There was this talk by Emma Watson, I think, called He for She. So I think that is a very enabling kind of attitude, that the entire society thinks deeply about it and try to solve it. Not men versus women or the other way around. Yeah.
Yes.
Prajwal.
I sort of agree with you, but I think we do need to take a comment very seriously because interventions intended for equity can cause harm. A classic example is the DST Career Break Fellowships. They were instituted for people who take career breaks, and they were given 3-year salary plus research costs and all that. An enormous number of women had benefited from it. There's no question about it. However, they didn't make it open to both men and women. They said it's only for women. But if it's a career break fellowship, it should be open to everybody. And I remember talking to the DST secretary at the time, and he said, who will apply for this? I said, I know at least 2 men who would. He said, no, let's take care of the women. But what happens is when, let's say there's a faculty position and there are 2 applicants and they are sort of on par and one happens to be a woman, then there is a tendency for the man to be hired and the woman to be told, you can apply for that fellowship, you'll get that woman's fellowship anyway. Correct. But the point is the attitude in instituting the fellowship is a patriarchal one. You can't have patriarchal interventions. Affirmative action is different, but you can't have patriarchal interventions which are based on a patriarchal framework that it is the women who have to cook and clean, that's why they have to, take breaks, and that's why we have to give them special fellowships. And if you look at the mobility scheme, have you seen the mobility scheme of DST? This is a few years ago they started it. It's meant to be for the so-called, couples, to address the couples problem. And it's again open only to women. If you read the advertisement, It's incredibly patriarchal. It's not, first of all, it's not open to men. And it says it's to help women undertake their responsibilities of taking care of their parents and this and that and all kinds of things. So it can cause harm, as she said.
So I relate to that because I remember, so we get something called childcare leave, okay, where up to, till the time, two children turn 18, we get 2 full years of paid leave for sickness, exams, stuff like that. Now, at a conference, I said this should be shared with the father. Okay, I was met with peals of laughter. It was a joke. Okay.
Only to women, this government scheme, a lot of young career men got up and said, how outrageous, we also want it. So that's wonderful. I told you this, right?
We like the young men. Okay. Okay. So thank you very much, Sonali. So our next speaker is an erstwhile member of our sports club. She's a sportswoman herself. She also does research on granular suspensions, and she's probably one of the biggest sports in RRI because she just agreed to give this talk on a very challenging topic. I think I just asked you on Saturday. Okay, and she has prepared a speech on how to get more sportswomen in RRI sports activities. Okay, Shevanti.
Hello? Yeah, it's too loud. Okay, hi everybody. I am Sebanti Chattopadhyay. I am a PhD student in the SCM department. And so to begin with, I'd like to thank Subbu and Ranjani for pushing me to give this talk actually. So when Subbu called me on Saturday, that, okay, so this Women's Day thing is happening, can you give a talk? So my immediate reaction was panic. I have stage fright. So I was like, oh no, I have to get out of this somehow. And then his next sentence was, you can give a talk on this sports thing that, there are so few women in sports. And I said, oh, sports, okay, fine, fantastic. No problem. So in the next few minutes, when I tell you my experience with RRI sports, you'll understand why I am so comfortable giving a talk on this. So I joined RRI in 2017, and in a batch of, I think we were some 13 people, 12 men, 1 me. So for the first couple of months, like almost my whole first semester here, I used to come to institute for the classes and interact with my fellow batchmates in SCM and maybe go for lunch, meet some other people and go back to hostel. And hostel I had some interaction with my immediate neighbors. That was it. It was a very boring life. And you wouldn't believe this, even I can't believe this now, that I was unaware there is a part of the institute behind the library. I was literally unaware of it. And I'm sure RRI has this orientation in the beginning for students, but I think I somehow missed it. So anyways, but I had always been a sports person. I mean, I've like throughout my BSc, MSc also, all 5 years, I had a daily schedule of basketball in the evening. So of course it was very boring for me initially. So then by the time second semester started, this one friend of mine, he was telling me, oh, we go for badminton and volleyball in the evenings and it's so much fun. I was like, okay then, can you just take me along with you when you go? And that was it. I have never looked back. And now I'm a regular, 4.5 years later, I'm a regular person who's there. I'll be there even if I'm not playing. I'll be sitting there talking to people and so on and so forth. So not just as a stress buster, I got to learn some new sports. I was a very rookie player in badminton. I had no idea how to play volleyball. But I can say that I'm a decent player now. And on top of everything else, through RRI sports, I have known some very fantastic people who I might not have known if I was just working in my lab and I was just restricted to my daily schedule of working in the department and so on. Now, one very sad thing that has happened in the recent years is the following. In my first and second year, there were a lot of women players. My seniors and other students, other RAs and BSPs. And they were such fantastic players. They used to give the men a competition. I mean, badminton mixed doubles used to be fantastic. people used to come and sit and watch those matches. It was so good. I mean, yeah, in the past few years, all this COVID and all things kind of got disturbed. But eventually, the number of women players has gone down significantly. I mean, if you go towards there in the evenings these days, it will be like a handful of women. I think, including me, I think there are some 4 women who come to play on a daily basis. So, when I was asked to give this talk, it was a little short notice, so I didn't have a chance to kind of take a general survey of why women are not coming. So I just discussed with a few of my colleagues, and from my own experience and understanding, I mean, we came up with a couple of points that we can do as a community in RRI, and a couple of reasons why women might not be coming in. So the first thing is, in RRI, we have like 4 outdoor sports. So we have cricket, football, badminton, and volleyball. So maybe we can introduce some more gender-neutral sports, like for example, maybe throw ball or frisbees or something like that. We can actually ask around the women like what sports activities they'll be interested in playing. Now, among the existing facilities, from what I have seen, people, especially women, are more inclined towards badminton. Of course, it's a safe game, and almost everybody can play as a beginner level, right? But the thing is, badminton is popular equally amongst men and women both. And we have only one court here. It's an outdoor court, so given the Bangalore weather, it's kind of difficult to play also. It's super windy in like a majority part of the year. But even then, there are still so many people who are waiting to play that if you go there to play, you'll sit there for like an hour. You'll get to play maybe 2 or 3 matches at max, and you'll be bitten by a bunch of mosquitoes, and you'll come back. You'll come back maybe even more frustrated than you were when you went there to kind of vent out your stress. So given that, I mean, so I was a part of the RRI sports committee till recently. It was a very cherished position. It was very hard for me to step down from there and let others continue. So I know that the sports committee has been trying to renovate the existing sports facilities in RRI. So maybe at this point I can make a request that if badminton can be prioritized a bit. I mean, I know that there is a plan of putting turf on all the grounds, but there are also plans of making more badminton courts, right? Yeah. So if that can be prioritized, I think that will be good for women and for men also. I mean, badminton is a very popular sport in RRI. So that's the first thing. Then the second thing is we can have some maybe like changing rooms in RRI. I think in all the buildings here, I think only this admin building has a washroom that has a changing room facility, which I think if 1 or 2 more can be established somewhere in the campus, it will be good. And then maybe we can have some, I don't know if it is possible or not, we can have some trainers that can come for a couple of months so that people will get some motivation to come and maybe learn the game and so on. And maybe we can have some annual or biannual sports day kind of thing. So usually what happens is we have tournaments for all the sports annually once. And during those times, there are often plans to have this inaugural match, and we try to inculcate more women to come for the inaugural match, but it's difficult. It just ends up being the usual players who are coming for the inaugural match, and maybe some faculties and so on. So since the tournament times are very competitive, so instead of that time, we can actually have a sports day in RRI where we have these mixed matches kind of things. Where teams are made of men and women, so they can compete with each other, and that will also help on another level, which I'll just come to. And of course, we can keep some snacks, and food is a good way of bringing people in. So okay, then the next thing, which according to me is very, very essential. See, the thing is, I mean, like in my case itself, I'm not an introverted person or a shy person in general, but when you come to a new place, you see this bunch of people, they all know each other, they're interacting and all. So it's very daunting to kind of go up to them and maybe get introduced or something. So similarly for the sports area, if you go there in the evening and see that whole bunch of people, you'll be like, oh no, let me just go back. No. So that's the thing. In my case, I had a friend who was kind enough to bring me along. So to other people in RRI, to the existing people, to the old people, it's my request to you that if you have women colleagues with you in your lab, in your office, or wherever, you know people who are coming in, just interact with them in the sense that if you are interested in playing, let me just take you to this place. You know, we have this wonderful sporting facilities, we have wonderful people who are playing there, let's just go. And even if you don't play, you can at least accompany them. You know, one familiar face in that area will be like such a confidence booster. And yeah, and in this respect also, the thing that I think could be helpful is interaction between people. So typically our interaction is very restricted to the immediate people around us, right? So if we have these mixed matches or the sports day kind of things where people can interact with each other, that will, I think, motivate more people to come in and play every day, women especially. Because I remember this one conversation I had with a colleague of mine, a female colleague, and I asked her, why don't you come and play there? I know she plays. So she was like, no, see, if I go there, I'm scared that, you know, I'm not such a good player, people will make fun of me. And that's a very legitimate worry, you know, all of us have that. But in my experience, I'll tell you that people in RRI are not that mean. They'll be nice enough. And I mean, give it a chance. Just come there, bring somebody along with you and just, you know, give it a try. Just try a couple of sports. You'll learn a new sport. People are helpful. They'll give you opportunities. They'll teach you also if you want. So, I mean, it's a fantastic environment there. Take it from me. Just one last thing that I like to point out is that this is something that the RRI community can do, so far what I have mentioned. But one thing is, as women players, to the existing players who are playing and to the people who hopefully will come after my talk. So I'll be telling you this, that this is something that I have also experienced. I have seen my other fellow you know, women players experience this. We are typically deemed as not so strong players, you know, like weak players. So in certain cases, the men who are playing with you, they might try to, you know, like if, for example, in volleyball, if the ball is coming to you, you're trying to take it, and some other person who's playing with you might come and just intercept that, thinking that, oh, no, you won't be able to take it, so let me do it for you. If that happens, call it out. It happens, and I have called it out, I still call it out, and it is essential. And they listen. People are nice, they'll listen to you, they will, you know, just tell them, okay, let me take it. Let me try. I won't be able to take it the first time, maybe also the second time, but third time I'll be able to touch it, so let me do it. So we just call them out, okay? This is essential. We need to stand up for ourselves as well. Okay, so finally, I'll just say that, you know, we do have excellent facilities here, and we do have very nice people in RRI, especially the ones who are playing, and you'll definitely find me there. So at least one familiar face will be there. So do give it a try. You know, just come one day, you know, just see how people are playing. If you come there, you'll feel like, you know, okay, maybe I'll also give it a try. So just take that one leap, and hopefully things will be better for everybody. Thank you.
Thank you, Shevanti. Thank you very much. We will come and we will call you out. And I see at least 2 members of the sports committee. There might be questions here. So I have taken notes, and we'll make sure together that, you know, some of these are implemented.
Hi, Shevanti. Thank you so much for that really nice talk. I might be one of those people who you have convinced to come back. I used to play before.
I know Mayuri, right? Yeah. Oh, I've heard so much about you.
I just want to bring it to the attention of everybody, and just to kind of get an opinion from everyone, not just you, for both men and women, is clearly in academia we don't work 9 to 5, right? So we continue our work later in the evening hours, so once we're back home on our laptops, so it's not like a 9 to 5 office hours. So why is, other than the weather, why is the preference to gather beyond 5 p.m.? Because some of us have restrictions of when we would like to commute or head back home.
That's true.
Is it socially acceptable to be seen playing in the badminton court during work hours as RRI as a whole? Do students feel like their advisors will frown upon them? No offense, but is there something that is causing this gathering only after 5? And what are there anything to encourage people to say it's okay, or if it's not, people should know? So that's one other aspect of participation in the evening sports that I'd like to bring out.
Yeah, you're right, actually. I should have mentioned this. So even me, I remember in my first year when I started playing the second semester. So first year we have a lot of free time, right? Only courses in the morning and that's it. So me and my couple of friends, in the SCM only, we used to start going in 5 o'clock. Okay, let's go play. But then we were like, no. If we go from here, people will see that. And badminton, you carry a racket and shuttle and go. People will know that you're going at 5 o'clock. Then we were like, okay, we'll go from the back side to avoid the main area, where people can see you. So that is a thing. I don't know. I don't think it is frowned upon, but it's something that people might judge you. Especially in your later years of PhD, that might come up occasionally. Oh, you used to play in the evening, 5 o'clock you were going to play, and now you're taking time to finish. That's might be one of the reasons.
Then you call it out. You have to call it out.
Yeah. But I think that need not necessarily mean anything. I'm pretty sure, like she mentioned, our work is not limited to 9 to 5. But I think by the time 5 o'clock hits, I think there is a cutoff switch that happens, and oh no, need a break. Whether it's a coffee break or a sport break or just to go interact with some more people. So I think that's the reason evening is more preferable. And I know some people are coming in the mornings also. They come to play. I think we can also start with that also. Maybe 7 to 8 o'clock, we can have a volleyball match. It'll be empty. And morning actually weather is much better. For badminton also, volleyball anyways, you can play anytime. So yeah, that's a good point. Yeah. Oh, yeah.
Yeah, that was really great.
Oh, thank you.
I just wanted to I was a little curious because when I was a faculty in the sister institution, Indian Institute of Astrophysics, and when I joined there as a young faculty, we used to play volleyball regularly, right. Students and me and everybody, and it was considered normal, men, women, everybody played together. And then there seems to have been a regression in terms of the participation of women. So I was wondering if you have thought about why that might be. Because it's not that, women were never participating and they've kind of trickled in and,
right.
Increasing in number. That's not how it has been. It was very normal earlier and then there's been a regression. So I was curious.
I think personally my opinion is that I think the interaction part itself, your interaction will be very limited to the very immediate people. So if they are not going to play, or if they are, okay, it's possible they are not going to play, but they still might be knowing more people than you know. So that's why I'm urging people to, bring their colleagues along. But that's a major thing. It is kind of daunting to just go there and see a bunch of people playing, and there are good players. So you might think, oh, I won't be able to play as well, they'll make fun of me. Or, you'll feel a little, okay, maybe not, maybe next time, or something like that. I think that's a major issue that we can solve. Other than that, of course, sporting facilities improving and more activities that women might prefer also. Like, for example, I was told that dance and Zumba, for example, IISc has this other like dance and all those clubs and all. I think that is more frequented by women. So all these kind of things, I think if we take a survey from the women in RRI, we'll understand more why this is happening.
I would like to also comment about IISc. You said that lately you noticed that less girls come in.
Right.
Actually, what I noticed, I live in IISc.
Oh, right.
That on the grounds, before, even like 2 years ago, let's say, we have that big ground.
Right.
And girls used to jog around.
Okay.
But lately, I don't see only guys walk and jog. This is also strange. You're right.
Yeah,
there are clubs. We still have aerobics and that Zumba. The girls are coming. But actual participation, I noticed reduced of the girls.
Yeah, that's
even
really
though just
sad.
simple jogging. Something to do with pandemic.
But I think now we are moving towards normalcy. People should be coming back to...
But that you mentioned it, I noticed.
Yeah, we should really look into this. At least a survey or something can be done. So I think we should definitely look into this.
We should do a survey.
It's essential. I see so many women here. I'm like, why don't you come? So many women are here. When I go there in the evening, I see only 4 people. It's really sad. Okay, anyways,
it is.
Thank you.
Yeah. Okay, if there are no more questions, let us thank all our wonderful speakers of the first session. So we will now go for lunch. And we reconvene at 1:30 p.m. where we have 3 more fantastic speakers. We have Nupur, who's a social entrepreneur, and she'll tell us how she started, so before RRI was paying money to BBMP for garbage, Now BBMP is paying us for our garbage, okay? So there's our, like PM woman of RRI #1. Then there's Palak, who works on materials. And then we have Prajwal, who will tell us about Professor C.V. Raman's probably most illustrious female collaborator, Anna Mani. Okay? So see you all at 1:30. Thank you. Yes, but we'll do it at 1:15. You can just copy. No, Gunjan gave a science talk. Yeah. So Naresh, if we close it, then we have to see this. That one is nicer. The screen. This is nicer. Okay. So shall we start? Becoming a social entrepreneur. Thank you. So are you going to just use the microphone there? Or would you like this?
No, I'm good. Any. So good afternoon, everybody. I'm actually really, really glad to be here today. And wherever I go, people ask to talk about solid waste management. I'm always talking kachra and discussing garbage. So it's really a nice change, and it's a privilege to be here in RRI. And it's a great opportunity for us to be implementing waste management systems here. So yes, I would talk about my journey. It started a few years back. So I'm an accidental entrepreneur. Never dreamt, never planned. It's just happened to me. So now when I look back, when I was younger, in my younger days, I just think that what were those factors or enablers which we were talking in the morning today? What made my personality? What was the kind of family environment or my convictions and the inspiration which I got from my grandparents or my parents, what made me what I am today. So I belong to a very traditional business class family in North India from Allahabad. In my family, the women were not working, and we were only the primary caretakers, and I was also brought up like that. I was a strong woman who tried to become a rebel. I mean, trying to rebel at home.
And I was a sprinter when I was younger. It was God-gifted. I was a champion of the city for 2 years consecutively. But again, that family pressure, which I had was like, tum PT Usha banogi? No, tumhari shaadi nahi hogi. Tum kali ho jaogi. These are really the exact words I'm trying to put here. And somehow, again, there was pressure from family ki padhai karo, and why do you want to become a sprinter? I mean, kuch nahi rakha hai isme. Paper mein 2-3 baar naam aa gaya, medal mil gaya. So I grew up listening to all these things, but I continued till I was in grade 12th. I continued to run, and along with sprinting, I was into dance and music, and of course, but let me tell you, I was not a science student. So I think in this hall, I was the only, I'm the only one, I think, who took arts or whatever you call those times. So I bow down to all the women scientists here. So I was not into, towards academic also. I was pure, like, dreamer and thinking, and I had no plans for my future. Dekhenge kar rahe hain, life is just flowing. And then, of course, as small town girls get married, I got married pretty early, and I was, dreaming of my life, married life. And I got married to a guy who's a pure science guy. And because of him, I got a chance to go out of UP and totally different life, absolute, a change. And from a protective household, I was there. He got a job in France, and I went off to France. So there, I think, seeds were sown where I said, okay, I have to do something for myself. I have to, okay, I was still the caretaker of the house, but there was life beyond it. So I started working on myself. That's what I realized, that I was very important. I think I was just 25, and I already had a baby. And I said, I have to start working on myself. And I did, again, studies. I got into studies, and then I took up a job, started teaching English in France, and then I got a job in a startup. That was something which was really kicking for me, and very challenging. And I realized that, yes, I had the caliber. I think all those years where I had seen my father was a businessman, and I was into athletics, very competitive, all those, positive experiences of my life started converging there, and it was a great experience. And I started, observing things in France. I was into that total observation mode and learning mode, which really helped me to become what I am today. It was very important. I realized that all the energy should be towards you. I mean, I was not, I did not do a professional degree, but learning did not stop. So that was very important. And that experience to work in that startup in France was a great experience, and I made most out of it. And then, of course, my husband moved back, and I moved back, and I got a job in Embassy of France in New Delhi. A very, the place looks glamorous from outside, and you would, when you enter those gates of the embassy, you forget that you're in India. You are dressed up, you speak French, and those after office parties and all youngsters, and it's a great ambience, but there was something missing. I could not, I was not content. The content of the job was very, clerical, and because I had worked in a startup before, I realized, no, this is not the place, and I was trying to figure out what I want to do. I had to do something meaningful. I'm in this 9 to 6 job, and the embassy is like, they pay me well, and it looks very happy from outside, but I was not. So I chose to do a master's in environmental sciences. I was, I think, 34 or something, and I have 2 kids now. And I enrolled in my MSc, environmental sciences, and I got, a lot of funny comments from good friends. Kyun kar rahi ho? you're such a comfortable job, and why do you want to just get put into trouble of studying for 2 years? I did not know what I will do with that degree, but I was like, I have to get into something where I could, which is more meaningful, give back to the society. It cannot be doing an MBA like everybody else was doing and sit in front of the camp computer. I had to recognize myself, what I want and what I'm good at. I was a people person. I was more of a social person. I was very bad with numbers, or I was very bad with management or whatever. So that's what I chose to do. And nobody supported at that time. Nobody was like, okay, curry, let's see what will happen. But I made sure that somewhere I knew that I was on the right path. And then we moved to Bangalore. That's where the real journey started. I still did not know that I will do solid waste management. And when I came here, I got to connect with some eco nuts in Bangalore, and I attended a session, an event about solid waste management, and that was my calling. I understood that, yes, this is what I want to do, but how? It was still a big question, and I had, of course, left my job. And everybody, including the family and friends, are like, what are you doing? Why don't you go back to work again? My children were telling me, Mama, why don't you start working again? And I was like, no, I don't want to go back into the well. I'm out of the well. And French embassy or any French corporate would have given me a job. But I said, no, I don't want to do it. So it was a long 3 years, I would say, which went into preparation to create pro-waste concepts. So there was a lot of networking, there was a lot of learning at the ground level to understand the realities. And then there was a realization that, yes, the model which I want to conceive, or my model about pro-waste model, is not just a service model, or just a waste management. Most waste companies do just pick up waste. There was something beyond it. And my idea was to bring professionalism, to bring solid waste management to the priority of institutions and communities. So that's how the concept of solid pro-waste was born. I would confess here that when I conceived this whole thing, I even did not know how to make PPTs. I was not confident because I had left work since many years. I was not doing anything, and there was a great, leap, and these youngsters were all IT very well, learned, and I had to learn to make PPTs because I had to go and give presentations. I had stage fear, and I could not, when I was invited to give a lecture, okay, that if you want to do solid waste management, come and give a lecture, I was like trembling. So all of those were the real ground level, realities which I had to work on and go ahead. It was one step at a time. And then finally, I started volunteering with some NGOs and groups in Bangalore and learning exactly what the problem was. I knew that I don't want to do which everybody else was doing. It has to be something which stands out. And finally, I got my first project in 2013. Again, it was a huge challenge. And I would go and talk to people that, okay, I would help you to convert your campus into a zero-waste campus, or I will implement waste management systems on your campus. And people were the look I used to get from people was like, really? I mean, they couldn't imagine that a woman who talks about waste management, and she says that she will not pick up the waste. What is she going to do here? Our campus is actually clean. We are the cleanest campus, or we are the greenest campus. We've got 100 trees on our campus. So all those kinds of looks and questions I would get. And but then luckily, someone gave me a chance. Okay, try. So I said, okay, I'll try. And then from then on, there was no looking back. So through references, through connects, I kept getting projects. And in 2014, I finally registered my company as a private limited company, OPC, one-person company. Yes, it has been a very challenging journey, but I would like to mention here that if you have passion, that is one thing definitely, but and if you think you can solve a problem, but doing it is most important. That's where the courage and grit or persistent is required, and to create positive impact. So this is how I founded Pro Waste Concepts. It's an ongoing process, definitely. We are implementing waste management systems for campuses. We are creating greener communities. So it is not just pick up waste and go and put it somewhere else. So it is much, much beyond that. We are change makers, or we are helping, we are enabling people to change their mindset and manage their waste. So that is what our USP is. And it has taken years of work and thinking and creating processes to create what I'm doing today. So that is all I would like to say. And I think women, I sometimes I go and tell people that some women, they feel lost, or they are unable to do what they're happy about, or follow their passions. That I tell them that I am just a graduate. I was just a graduate in economics and English, and if I could do it, because it needs hard work and following your dreams and grit and courage. So anybody can do it. That's what always I go and tell people, that you don't need those, okay, of course you need those professional education or whatever, but that doesn't mean that if you're lost and you can't do anything. It just requires passion and hard work and grit. So that is what my learning has been, and I always tell women that don't stop, keep on going ahead, and don't care about anybody putting you down or giving you lessons that, okay, this is not done. Even when I was starting Pro Waste, people said, what are you even trying to do? Are you working in garbage? Or, this is just a passion. You can't make it as a full career. I mean, I even got comments like, how can you do field work? You're a woman. So all these kind of things should never pull anybody down. I think those comments should be negative, should be converted into positive, and then there's no looking back. Thank you so much.
Comments or questions?
So it was very nice to hear you speak. So I think from morning, you are the only entrepreneur we have in our list of speakers today. So just today morning, I read an article which said that it's 40% or 50% more men are likely to get funded in case of entrepreneurship compared to women. So did you face anything like that, or have you ever felt like that?
Taken seriously, but I'm very persistent. If you don't know, go to hell. So,
That's how it should be. Yeah. Okay.
I don't call myself woman entrepreneur.
Done. Yeah.
The first time when she came and met us, we were wondering, where does she get energy from? She was so passionate about... no. Yes, yes. True, 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 true. So 2 years back when we met her again, we thought, okay, let us try. So to tell you frankly, we thought we are very clean. She took us for a walk and she said how unscientific you are in terms of waste management. So we were, to tell you, all of you frankly, we were paying money to get our waste taken out from the institute. But after she took over this solid waste management in our institute, within 3 or 4 months, we were getting money for the waste. So she has created systems in such a way that people would come and buy our waste and pay us and then simply go. And all the kitchen waste, she had made sure that there is a compost pit and all the kitchen waste goes into the compost pit. Except for paper and plastic, there is no other waste which goes out from the campus. So, and to be on the lighter side, she is so persistent, she will come behind and she'll say, okay, Naresh, we should do this. So, on some days, when I see her, I'll walk in some other path.
Campus once a month, and they make sure the days I am there, some of the people go on leaves. And they take leave and go, Madam, sir mein dard hai, Madam, tummy upset, or my child is sick. I said, yeah, I know. But I will not leave them. So, thank you so much, Naresh. And I know that I have been, I go to his office, and now I think it's reduced because first year is very crucial to implement systems. Now, it's more or less, it's all done, so I don't trouble him. I don't trouble him at all. But yes, if we don't create this change, it will never happen. So that was what ProWaste wants to build. We are not cleaning up or, trying to just look deceptively clean. So that is what I was mentioning. It took 3 years of ground level research work to create what I was doing, and nobody would understand. My husband, my family, and sorry, but it's like mother-in-law thing. Why don't you start teaching in a school? I was like, what? Teaching is a very, very honorable job. But some people take it as an easy-going thing. So they were like, why are you even struggling with waste management? Why didn't you just become a teacher? So those were the kind of comments and I used to get. But I said, I knew what the vision was in front of me. So that's very important. You can become entrepreneurs in any, you choose whatever you're passionate about, or you can find the problem and start solving it. It can be waste management, I'm art side or science side, whatever. But that vision, that passion, it has to be, something which has to be guiding you. That's most important.
Thank you so much. Thanks, Nupur, for your very inspiring story. So, and thanks for agreeing to give us a talk. So this all happened at the parking lot the other day. So our next speaker is Palak, who will give the second science talk. So she works on materials. I forced her to give this talk. I don't know if she wants to give this, but she has some lovely videos that I think, we'd like to show you.
Am I audible? Okay. Actually, I'm quite loud. Maybe I don't need a mic, but yeah. So you can tell me when to slow down if it's too loud. Okay. So good afternoon, everyone. I am Palak. I am a PhD student in soft condensed matter growth, and I'm working under the guidance of Professor Anjani Bandyopadhyay. So the title of my talk is Control of Interfacial Instabilities using, okay, I can remove my mask maybe. Yeah. So the control of interfacial instabilities using a non-Newtonian fluid. So as the title suggests, it's like interfacial instability. So today I'll be talking about the interface between the two fluids, and one of the fluid is non-Newtonian fluid. And so what is all about, like interfacial instabilities? So you have two fluids, and when your less viscous fluid displaces a more viscous one, so then it gives rise to the formation of intricate patterns. And this is always the case when more viscous is displaced by the less viscous one. Now what we want to see, like what will happen if you take one fluid to be complex enough, like the non-Newtonian one, and how will it affect these patterns, like how will it affect the morphologies of these patterns. And so these kind of patterns you see everywhere. So before proceeding to that, I just want to mention, like, this work is done in collaboration with Weber, who is sitting over there, and my senior Debashish Shah, who is in right now in University of Düsseldorf doing his postdoc there. So yeah, so as I was talking about the patterns, like the nature is full of these patterns. You see a lot of these patterns around you. For example, in the tree branches, mud cracks, in the river network formations, and even in human lungs also. So in this case over here, like the tree branches, so have you ever wondered why the tree branches grows in this way? I'll tell you. So these tree branches grows in this way to get an optimized light exposure for its leaves and oxygen exposure for the tree. So this whole process of like this branching and all has a motive of like getting an optimized function to grow. And even like this one fascinates me a lot, this example. So the human lungs, you see these morphologies in the, like the vertebrate airways. So imagine if human lungs don't have this branch network. And imagine a simple shape, say like a sheet. So now this has some area, right? So imagine if it would have that sheet shape. So the area, equivalent area required to do their function, the same efficiency as they are doing right now, well fitted in our body, will be equivalent to 2 tennis courts. Imagine that. So that's the importance of these branch networks, like this is important. But let me tell you, this is not always like, okay, we want the intricate patterns, these are so fascinating. There are certain fields where you don't want these instabilities to occur. You don't want these interface instabilities to occur, those patterns. You want a stable, beautiful interface between these. So the area is like, basically the one where from this whole problem is originated is the petroleum industry. So during the extraction of crude oil from underneath, so water is pumped with high pressure to extract the oil from the porous band, and there these tons of water were absorbed while like during the recovery. So that affects the efficiency, right? Like the extraction of the oil. So there you don't want this instability. So our motive is like, okay, we need a control. We need an active control of these instabilities, okay, whether it's enhancement of these instabilities or their suppression. So we should be able to control this. Depending on our requirement, we can do it. Now, all these things are like very large scale process, right? So how to do it in lab? How to do it in lab? So that's what we are doing in our lab. Like we are controlling these instabilities by using non-Newtonian fluids. Okay, so the system, as I said, like one of the fluid we are using is a non-Newtonian fluid, which doesn't follow the Newton laws of viscosity. It shows the complex flow behavior. So the one which we use is the laponite, which is a synthetic clay. So unlike the natural clays like bentonites and all, it has like a lot of polydispersity there. This is a synthetic clay which has like this monodispersed dish-shaped particles. So having diameter 25 nanometer and about a nanometer thickness. So on the top left side, what you're seeing is a schematic like showing the laponite structure. So it's an inorganic molecule having octahedral sheets sandwiched between 2 tetrahedral sheets containing these elements over here. So the laponite comes in. Yeah, sorry for the break. Okay, so as I was telling, so this laponite comes in the powder form. It's a white powder.
and which, by the way, is very hygroscopic. Basically, it absorbs moisture quite fast. So before any kind of use, you need to bake it in oven to remove all the moisture. So as I said, like these are dish-shaped particles. So in its original form, it forms like these tectoids, the stacks of these dish-shaped particles. Now, what will happen when you dispose this powder in water? So these blue things are like the laponite disk, having sodium ions in the intergallery space. So when you dispose these laponite particles in water, so the sodium ions start coming out in the bulk due to the osmotic pressure gradient. And as a result of this, the sodium ions is Na-positive, right? It comes out, so it gives a negative charge on the face of this particle. Now, these two disks have like the negative charges on their faces. They start feeling the repulsion force. And as a result of which, they like fall apart, like it exfoliates, and you have these separate laponite particles. So, the charge on the rim is pH dependent, like in which medium you are suspending these particles. So for example, in water, so deprotonation at the rim of these laponite particles give rise to a slightly positive charge on the rim. So this whole process like happens over time when you dispose it and the sodium ions are coming out and all. So the time-dependent electrostatic interactions between these heterogeneous charged particles give rise to the formation of this kind of microstructures. So this is a schematic of like commonly used house of cards structures, basically this arrangement you are seeing over here. So this positive on the rim and the negative phase charge, these laponite particles are forming this kind of structure. So just by merely like this system is like evolving with time. So you just keep the system for time and then it transforms itself. So it ages, that's how, like this whole process is happening with time. That's why people call it as an aging material also. So we just add the powder in water, stir it for enough time, and then filter it to use for the experiments. Okay, so I'll just show you this thing. So this is a photograph taken like just after the sample preparation. So this is a glass vial, and by this you can see it's a liquid-like, right, when we tilted it. So what we have done is like we kept it for a day, 24 hours, keeping it undisturbed and taking care of the evaporation. There shouldn't be any evaporation. I'll show you. After 24 hours, it transforms into a soft solid. So when you tilt the bottle, it's sustaining its own weight. So this is a very beautiful system, nothing to do with it. Let's just give it its time, and it transforms itself. So now we are talking about this viscoelastic material, this non-Newtonian fluid, which has both viscous and the elastic property, because it's getting solid, right, with the time. So it has this both viscous-like properties also and the elastic properties also. So we have done some rheology, which is a study of the flow and deformation. So you apply some, you see like how the flow will be when you apply some deformation to the material. So I will not go into the very much detail. So just think like, okay, on the left-hand side you have one plot where on the y-axis you have these two symbols, G prime and G double prime. So this G prime is basically the storage modulus, which tells you about the viscoelastic solid-like behavior of your material. And G double prime tells you about its viscoelastic liquid-like behavior. So these two parameters tells you about both the viscous and the elastic behavior of the system. And on the x-axis, you have the waiting time. So waiting time or aging time, I'll use it interchangeably. So this is the time for which you are keeping your sample. So if you see over here, these solid symbols are basically your G prime, and the hollow symbols are your G double prime. So at initial times, you see like the G double prime is dominating over G prime. That means in this time regime, it's behaving like a viscoelastic liquid, as you can see from here also, like it's a liquid-like. But you wait for enough time, and like with time, so G prime starts dominating over G double prime. That means the system is becoming like solid-like, and its elasticity is increasing, because G prime is increasing, and it's more than G double prime. So this is the time regime where you have this, like the formation of these structures, which give rise to this rigidity to the sample, and that's how it's becoming elastic with waiting time. And on these two plots here is the flow curves, which basically just tells you about this viscosity versus shear rate variation. So as I said, these are non-Newtonian fluids. So this one is for laponite suspension. So it doesn't follow the Newton laws of viscosity. That's why you are seeing like its viscosity is changing with the applied shear, like the applied deformation. So these different colors over here are the different times, waiting times. You can see that this is on the log scale. So you can see like there's a change in the viscosity, but our main concern is about the elastic property of this material. And the bottom, it's the other two fluid. As I said, interface and stability is about the two fluids, right? So the one fluid is the laponite suspension, and the other two fluids, like the different fluids, is the water and mineral oil. Both are Newtonian fluids. That's why their viscosity is independent of the applied shear rate. I'll tell you like what's the reason behind using these two different fluids like water and mineral oil. But in one set of experiments, it's like a displacement of laponite suspension with water. In the other set of experiments, it's the displacement of laponite with mineral oil. So with water, is something like you have laponite in water, so the water mixes well with laponite, right? In the second case, mineral oil doesn't mix with water, right? So it has this interfacial tension, the surface tension between two fluids. Okay, so as I said, like to study these instabilities on the laboratory scale, people do often use radial Hileshow cell, which is just like, it comprises only 2 circular glass plates. The main condition is like you should have the confinement very less. So here is like 170 micron gap between these 2 plates. And the top plate has this central hole. So with the help of this hole, we fill first the aqueous laponite suspension in the cell, and then the second fluid, either water or mineral oil, is injected in the same cell. And we look at the profile between these 2 fluids, like how the interface will grow in the different scenarios. And yeah, so we inject the fluids with the help of a syringe pump, which decides like what should be the pressure like to fill the fluids, like to displace the fluids. Okay, so as I told you about this waiting time, right? It ages with time, it transforms with time. So let's see, so what we have done is like you prepare the laponite suspension, we filled it in the Hileshow cell, and then waited for this time, this predetermined aging time. Then we have injected the second fluid, like see how it reacts to the, like the inner fluid which is displacing it. Okay, so to play this, can I? Can you see at low ages when it was like liquid-like sample? So this dyed thing is the dyed water over here, and the gray background is basically laponite because it's transparent, so it's the sheet color which you are seeing from the top. So as you see, like at low ages, it's like a dense viscous patterns, like you have these fingers and they are constantly merging. Now let me show you what will happen if you increase the waiting time. Okay, so now you have the well-defined boundaries and you eventually got this dendritic profile of the interface, dendritic patterns having these side branches. As I told you, like with the time, so its elasticity is increasing, it's becoming like solid-like. Till now, it's like the displacement, right? It's displacing. Now let me show you, if you waited enough for a day, okay, it actually fractures the outer media. It actually fractures the laponite suspension. So just by like a single concentration, a fixed concentration, fixed displacing rate, we have observed a wide range of interfacial patterns with the system. And if I, okay, yeah. So these are the different patterns you see on the screen as the different waiting times, this TW. So we have observed the transition from dense viscous pattern to the viscoelastic fractures with the dendritic patterns at the intermediate waiting time. Now, as I told you, this was about like the displacement with water. So now what will happen if you incorporate interfacial tension also? So everything will be same, these waiting times, the displacing rate, the flow rate will be same. It's just the inner fluid, basically the fluid which is displacing laponite is replaced with mineral oil. Okay, so now you no longer have those fractures. Though the elasticity and everything is the same, outer media is same, everything condition is same, you have this additional interfacial tension between the two fluids, and we eventually see the flow stabilization effects of this interfacial tension. So we observe this flower pattern at the low edges of laponite suspension. Like you see this like a flower petals, thick protrusions, and at high edges, we saw this like the jagged pattern. So jagged, basically, you can see like this, the curvature, the jaggedness at the interface. So again, just the simple single fluid pair, we have observed a wide range of interfacial patterns. But that's not just the end of the story. So what will happen, as I was telling you, like the displacing rate is same and everything. So what will happen, okay, we know like something is definitely happening at the high edges where the suspension is in the elastic state, it's becoming solid. What we have done, like, okay, we fill the laponite, wait for 24 hours. Now what we have changed is like the displacing rate, with the pressure with which you are displacing it. So we have got the same sequence, we have restored the same sequence of interfacial patterns just by changing the flow rate, like the displacing rate. So we have seen like the viscoelastic fractures at low injection rate, and at high injection rates, we have observed this dendritic pattern. So basically, what is happening over here? So you have this formation of structures, right? So by increasing flow rate, what you are doing, you are disrupting those structures formed in your suspension. So at low flow rates, your elasticity is sustaining those applied pressure. That's why you have this viscoelastic fractures. And at high flow rates, you have this dendritic pattern. Similarly, over here, we have observed the same transition from jag pattern to the flower pattern with increasing flow rate. So just by using a single fluid pair and using its aging property, we have observed this wide range of interfacial patterns. Now, we have seen these features, right? Now, we need to quantify them, like how we can quantify, how we can know, like, what are these patterns, what will be the pattern, what will be its quantity, who can tell us, like, which kind of pattern it is. So we have calculated a ratio, which is the ratio of two areas, AP by A. So AP is the pattern area. So here, the gray background is your laponite, and the black, again, is your inner fluid. So this black portion area, the area of this pattern is AP. And the pi r square is the area of the circle, which comprises this whole pattern. So it's a fully developed pattern. It's at the later stage. So it's not at the onset. It's a fully developed pattern. So by just using the areal ratio, we are quantifying these patterns. Okay, so here is this ratio versus the waiting time. The first parameter which we saw is the aging time, right? So here you can see, from just by looking at the patterns, you will see, okay, yeah, this should have the more ratio, more area, and compared to this one. This is what is reflecting over here. So the black squares you are seeing is for the miscible case, like for the water case, the black patterns, and the red ones are for the mineral oil case. So as from the patterns, you can yourself see, okay, so in this direction for the miscible case, the areal ratio is decreasing, and for flower pattern to jag pattern also is decreasing. And since this immiscible case is where the interfacial tension is there, so it's more thicker protrusions and all. So for all the sets of experiments, the areal ratio for immiscible displacements, like immiscible patterns, are always greater than their miscible counterparts. Similarly, for the case when we plotted this versus Q, which we have changed in the second set of experiments, so there also we have seen there is a change in the areal ratio, the similar changes in the areal ratio with the increasing flow rate also. Now, what we want to see, okay, so we have seen these morphologies, the areal ratio we have seen. Now I want to tell you, this just by the areal ratio, we have segregated all the observed morphology in a single phase diagram, spanned over the waiting time, your flow rate, and of course the interfacial tension between the two fluids. So these are the different morphologies which we have segregated on this phase diagram. And the colors over here shows the different morphologies. And these are the values, the colors are corresponding to the logarithm, natural logarithm of this areal ratio. I want to tell you, as I said, it's about the control of instabilities, right? So we do have observed this stable interface also with the same system. If you displace a low-aged laponate suspension with a high flow rate, like mineral oil, you can eventually suppress the whole instability and end up having these stable interfaces. So that's the moral of the story. So by just using this clay suspension, one can control the instabilities and these shear and the time dependent, the time dependent, basically the aging time, and this shear dependent rheology, depending on the flow rate, can actually go on to the pattern morphology. And this is the first time when the aging time of this clay suspensions has been used to control these instabilities. So we propose that this can be a reliable control parameter in future to control these instabilities. And of course, the pattern areal ratio, just the ratio of the areas of the pattern with the area comprising it, can actually segregate the whole wide range of morphologies. And plus, this study can help in predicting the interfaces in the case of the mud and slurry displacements. So I would like to thank Professor Anjani for the good and engaging scientific discussions and to come up with this and her guidance in the work. Of course, my lab mates and the workshop people for their help with the experimental setup. Is Vaibhav and is Debashish. Thank you guys for your attention.
Supurna has a
in the aging process, it's a competition between the waiting time and the relaxation time of the system, isn't it? Is there a typical relaxation time which characterizes the Yeah, because if you look at the transition, that G prime and G double prime, the time scale at which that transition from liquid-like to solid-like behavior happens, there's a particular time scale that it is singles out. Roughly, yeah.
Yeah, so after which, like, because it's happening with the time, right? So the time is getting, like, enough to span the whole system, the whole network, like, whole available space. Then only, like, your elasticity will be such so much high that you can actually see the dominance of your G prime over G double prime.
Mm-hmm.
There's this, like, critical value, like, after which
yeah. I think there's a connection between the spatial scale morphology and the time scale, perhaps, yeah. Perhaps, I mean, I'm just guessing that the onset of those patterns, onset of the rigidity network.
So you're talking about during the displacement?
No, just the G prime versus G double prime, that times the plot of G prime, G double prime versus waiting time. That simple curve in the beginning. Yeah. So there is a time around, right.
Yeah, but so this is happening with the time mode. So it's kind of so as I showed you, like these sodium ions are coming right out of the system. So this your sample is continuously like starting. So these sodium ions is also like coming gradually with the time. Then only these structures will form because after getting this heterogeneous contribution. So this everything is happening together. That's why it's all about its ages. You just need to understand that it's going to react to the time.
Thanks.
Any other questions?
Okay, if there are no other questions, let's thank Palak, and we'll go to the final talk of the day. So our last speaker is very well known in RRI, though not exactly of RRI. She's very famous for her, very well known for her work on supermassive black holes and active galaxies. She's also very well known for her deep commitment to minorities issues. And she's going to tell us today about the weather woman of India, Anna Mani, who also has a history in RRI. Okay? So thanks, Prajwal, for agreeing to do this. His thesis there, by the way. We just got it from the library.
Yeah, so thank you very much. It's always a pleasure to come here and speak. It's funny that I actually gave a talk on Women's Day here 15 years ago. So I was just wondering about how things have been since then. I don't know what actually qualifies me to talk about Anna Mani. Perhaps one thing is that when I was a young PhD student, I was a TFR student, and we had a building on the IISc campus, and we used to hang around a lot in the Raman Institute, especially in the library and so on. And it was sort of one big community, and so I encountered her a lot at that time, and it was something really fantastic. This is how I sort of remember her. She was the quintessential scientist. I mean, she just had science written all over her. That's the only way I can describe her. Of course, she was also the quintessential Gandhian, and she had this no-nonsense persona, and she would just walk into a room. She would always have something non-trivial to say. But for me, in particular, I think it was very refreshing to have her around, because there were not a whole lot of women then in science, and the attention one got because of being a woman was, it used to often get very oppressive, and there were very, very few people who treated me as a science student first and a woman or whatever after. Vijay Kapahi was one of them. I was very lucky because he was my supervisor. There was Ratnakar here in the library and Srini, who were two others who were like that. And of course, Anna Mani was very much like that. So that was really, really refreshing. So it was really nice to have her around, and she had a very positive, shall we say, impact into my times those days. And I guess the second reason that qualifies me is that I'm very proud to have been part of the Astronomical Society of India group which instituted the Annamani Memorial Lecture Series. And this is the group for gender equity. And so the idea is that gender inequity is a social problem, and therefore we need inputs from the social sciences and history and philosophy and all humanities and all these other disciplines in order to be able to address the problem. And so the Annamani lecture series is about that. So I actually went back into my backup drives, and I did actually find my presentation from 2007. And this is the question I tried to ask at that time. Some of the things really made me laugh. I mean, certain things I framed, I think, correctly, as in I still agree that that's the way to frame them. And this is how I kind of put my vision, saying, I happen to be a woman, but I'm hoping that someday, at least in scientific settings, that fact would be only as important as, say, my taste in fiction or my competence in fishing. And then I put across these fantastic quotes which had really inspired me and many of us at the time. I think, is Rita still here? Yeah, okay. I won't read the quotes, but Ursula Le Guin is a big favorite of many of us, and The Left Hand of Darkness in particular frames the gender issue very, very strongly. I won't read out this quote. It can be found on the internet, but they're very, very powerful quotes. And I also set out the reasons why gender inequity in the sciences is different from, or why is it special compared to gender inequity everywhere else. And these were the three reasons I put forth, and I think these reasons apply globally, but here there is perhaps also the extra reason about the idea of merit and brilliance and genius and so on, which negatively impacts inequity on all dimensions, which I didn't have here at the time. And of course I talked about rigorous enforcement of the gender equity cell activities. And then I had shown this poster. This was some conference. I thought it had been organized just before I gave my talk, but the dates don't quite match. But this was a conference in TIFR, International Cosmic Ray Conference, and just see how the members have been listed. So on the right, you have the you have the National Organizing Committee. And of course, there are no within bracket Ms. people there. But in the International Advisory, what's it called? Council, I think it's called. Committee. International Advisory Committee, there are within bracket Ms. people from China, Russia, and the US. And then within bracket Ms. people also in the organizing committee. And I remember writing to them about this and also copying some of these people. Only Virginia Trimble replied back. So I ranted about this in my talk in RRI. I don't think anyone thought it was very important. They thought I was ranting about something quite trivial. And this is what I said at the time, and I was really laughing about this because I completely disagree with this now. At that time, I said the primary deterrent is the socio-cultural factor, which absolves male members of the household from sharing responsibilities. So I think all of you know that Annamani was born over a century ago. Actually, she had her early life and education in Kerala. She did her college in Madras and then won a scholarship to do graduate studies because of her performance, and she came to the Raman Institute to do her graduate research. And you perhaps know that somebody called Kamala Bhagwat Shoni had a few years earlier paved the way for women to come into this institute, because otherwise it would have been impossible. When Kamala Bhagwat, who was a topper of Bombay University, applied for graduate study in the Indian Institute of Science, where Raman was the director, he refused her admission simply on the ground that she was a woman. And she then went on dharna, kind of, and then he relented, but with extremely humiliating conditions tied to her admission. She nevertheless came. She had a very good advisor and did very well after that, and then a PhD in Cambridge and so on. So anyway, she opened the door for women to come into graduate studies, and so by then, I guess Raman had shifted here, so there was Annamani, and there were a couple of others as well. There was Lalita Doraiswamy, later who became Lalita Chandrasekhar, and Sunanda Bai, and Annamani. So she went on to become a pioneering Indian physicist and meteorologist. She started her career right after independence and carried out path-breaking research. And it's important to remember that she was born at a time when the women's literacy level in the country was around about 1%. And she was only born about 60 years after Savitribai Phule and Fatima Sheikh opened the doors of education to people who were other than upper caste men in India. And many of you perhaps know the kind of circumstances under which they did it. They were both friends. Savitribai Phule and her spouse, Jyotiba Phule, who was also, they were both together very committed to education for all. They were thrown out of their house because of this, because they dared to open the doors of education to anybody other than upper caste people. And Fatima Sheikh gave them shelter in her home and also gave part of her house to start their first school. And then she got into it as well. And so Savitribai Phule and Fatima Sheikh went to Ahmednagar, trained together, teachers training, and then came back, and Fatima Sheikh also learned Marathi, and they both taught in the school. And it was said that they would walk to the school with an extra sari in their bags because they would get pelted and thrown cow dung at them and so on by the sort of upper caste interests who did not want education to be open to all. And roughly several decades after that is when Annamani was born. And so it was a very sort of a churning period. But of course, it was not one uniform thing across the country. The national movement had also taken off. She had a father who was, I guess they came from a Syrian Christian family, but he was a practicing agnostic. He always taught her, she said, to question everything, which was, I think, huge cultural capital for her. Education, because of the circumstances in Kerala, was free up to high school in that state. She grew up during the national struggle. She was heavily inspired by Gandhi and the Vaikom struggle against caste oppression. So Gandhi had visited at that time, and I think around then is when she really sort of became this Gandhian in every sense of the word sort of thing. Sarojini Naidu at that time became Congress president. That was very inspirational for a huge number of both men and women. And that kind of politicization does build, huge cultural capital. And so that stood her in good stead, I think. So she came into the Raman Institute as for her PhD. But she was completely deprived of intellectual discourse, because although Raman, with the experience of Kamala Shoni, did open the doors for women students. He believed in gender segregation, as a result of which the women students, so Sunanda Bai also entered the Raman Institute. I don't remember exactly when, but they were kind of contemporaries, Annamani and Sunanda Bai. And so they could not interact with the boys, with their fellow PhD students and so on. So this whole business about intellectual discourse and discussions and free-flowing chats and all that that we take for granted when we have been students was denied to both of them. And of course they had to face things like aspersions that only women who don't get married join Raman's lab. Sunanda Bai was actually officially married, but apparently her spouse lived elsewhere and people thought she was not married or something. But whatever, I mean, either way, this should not have been something they faced. There would be disparaging, very carefully chosen nicknames for the women students. They did research which involved very long experiments, and so did the men, of course, but the men could take naps and things sort of anywhere, in the passage, in the lawns, or whatever, whereas the women felt constrained to not do that, so they would crawl under their tables and nap there in order to rest during these long experiments. She landed up publishing 5 single-author papers, but was denied a PhD. I'm sure all of you know that story. The pretext was that she didn't have a master's degree. So that is why I mean, it's sort of nice, I think, that the theses are held in the Raman's, in the library, in the Raman's library. So they are just there, sort of nondescript. Both these people, Sunanda Bai and Annamani, did not get their PhD degrees, despite of having done PhD research. In fact, Sunanda Bai, sadly, just before she was to leave for Sweden for her postdoc, she took her own life, and it's not clear why, which had a very negative consequences. Masters, yeah. Sunanda Bai, I don't know. There was something, yeah, I don't know. I think when she was going to go to Sweden, her aspiration still was that that would get sorted out and she would get the degree, but apparently it didn't. So, yeah. So anyway, like I said, Nawani had a lot in her. She got a scholarship to go to England. It didn't seem very palatable at first because she was a very staunch nationalist, and how do I take a scholarship from a colonial power? But then somebody convinced her that this is actually national money. I mean, it is the colonial powers have made money off of us, and so it's fine to take that scholarship and go to England. So she did that. The scholarship was not for physics, but for meteorology, so she plunged into that. She did not get shackled by the institution of marriage. In fact, she seems to have had very, very negative views of the institution of marriage. Several of her somewhat, I mean, she had a really good sense of humor, so she has a lot of humorous comments to make about that. And then there was her very illustrious career in the meteorological department after she came back, which was right around the time we got our independence, and she did a lot of really outstanding work. Mention worthy are many things, but I just put down here the building of the ozone sonde, which India was one of the 5 countries to develop an indigenous ozone sonde. And so she was made a member of the International Ozone Commission. And she also played a key role in India's first rocket launch at the behest of Vikram Sarabhai, she built a meteorological observatory at Tumba, and of course it was a very successful launch, and it was a landmark event in our science and technology history. And she retired from the department, and then she came to the Raman Institute again as a visiting person. That is when I knew her as a PhD student. So what about these obstacles that she faced? Where are we with those kinds of things today? The Astronomical Society of India, the Working Group for Gender Equity, did a survey a couple of years ago. And so this is where the fraction of women faculty in the elite institutions in astrophysics stand. So you can see, of course, RRI is there. It is definitely better than during Annamani's time or during even my time as a PhD student, but lots to walk ahead. And the survey also asked people about perceptions. So there were the respondents to the survey were 45% women, and the women more than the men dominated the under 50 cohort in the responses to the survey. And some of the so the survey results are still work in progress, and people like Harvinder Jassal and others are working on finalizing them. These are some select results that we published in a conference last year. So, for example, 22% of the women reported having faced sexual harassment. 38% women and 38% men reported knowing someone who faced sexual harassment. 83% of the women and 43% of the men perceived gender discrimination in academic institutions. Majority respondents reported absence of workplace childcare. Most felt that the gender gap was due to societal constraints on women, like what I thought in 2007. 91% of the women and 85% of the men felt that childcare facilities in the workplace would reduce the gender gap. 80% women and 70% men felt mentoring programs for young women would help reduce the gender gap. And most felt that open discussions on gender discrimination were needed. And it's kind of interesting here because you do have a very, very large fraction saying number 3, which is that they perceive gender discrimination in academic institutions. And despite that, they say that it is these societal constraints on women which are a result of the gender gap, which is kind of strange. And also that, mentoring would help reduce the gender gap. Yeah.
43% men who perceive gender discrimination of women, right? Against women.
Yes.
Just
because
to be clear.
yeah, sure. yes. Yeah, you're right. I mean, I can't remember the details of the question asked. I assume that is the case, but we should check that. Yeah, next time we administer the survey, we should.
I also wanted to. We've had in discussions with students. Like the ethics class last year, it wasn't the predominant idea, but some students did say, "Oh, but what about discrimination against guys?" So there was, we had the discussion about affirmative action.
Right.
Yeah,
No, we do. Sorry. No, I was saying we do need to clarify that very, very carefully. Yeah.
No, the last point, that open discussions. Actually, this is a very important point because if you just look at the audience today, this is a Women's Day audience. Okay, there is a fair representation, but there could have been many more men over here.
And actually,
I
in
mean,
2007, when I
yeah,
gave the talk, there were a
especially
lot more
men
people in the
faculty,
audience.
Men faculty, I mean, I can
Yes.
see Pramod, and I think Shantan was also there. But other than that, I mean, it's a
Yeah.
very glaring absence.
Yes.
I-
And
I
that was a
wanted to
little
comment on
different. Yeah, that was actually different in 2007. I remember that very well.
I'm going to interrupt you. So our male colleagues claim that they are watching the live streaming. So I don't know how true that is.
We're watching them watching us.
Yes. Yes, we should.
Right. So about the fact that the gender gap was due to societal constraints, I don't want to present a whole lot of data. There are data, but I just wanted to point this out, that if you look at PhDs in science who are employed in higher education in India, about 45% are women as of 2015. I need to ask Sachdeva how she got the more recent results, because I was not able to decipher the results from the recent survey. Yeah, I know Aisha, but the thing is I just couldn't get the data in a form that I needed. So I should talk to you as to how you got that.
One quick clarification. In the respondents, are they all from those institutions that you listed?
Mostly yes, because it's astrophysicists at the Astrophysics Conference, the annual Astronomical Society of India conference. So they administer the survey at the conference.
So it is not
although I think there is now, it's online, so it's possible that people could, but it would then go to astrophysicists or members of the society, as in, it would go to members of the society plus the others who are not members but who come for the conferences.
But it could include university as well? Because I'm curious
No,
about that 23%.
some of them are from universities. Now there are astrophysics departments
in
universities, right?
Okay.
So
it's not just the elite?
No, it's not just the elite, but it would be dominated by...
and the 23% sexual harassment is a very large figure. That's why I wanted to understand that.
Oh, right. Yeah, that would, if anything, be larger in the elite institution. I just wanted to point out that the gender gap in physics is 20% in this number. In this number of science PhDs employed in higher education in India. So there can't be such a difference between disciplines if it is societal expectations which are playing the major role. So that was one rebuttal of these perceptions in the survey. The other thing is about the mentoring. So the last but one point, that mentoring young women would help reduce the gender gap. This is another myth, according to me, because if you look at the data, the pie chart, the donut is the Inspire Fellows, and there are more young women than men winning those in sciences. The plot on the right is the Indian Academy Summer Fellowships, and it has a plot of both the applicant pool and the selected, and in both cases, one is tracking the other, which is good, but there are like 60% of the fellowships are won by girls or women. This is for undergrad, actually, so women. So I think the idea that young women or girls are not interested in science is a myth, at least in India. And this survey, which is published in Current Science a few years ago, of 4 high school students from 4 schools in Dehradun, they tested perceptions, and they asked, for example, they put the statement, fewer girls than boys are interested in higher studies in science and math, and many more boys than girls said yes. Here boys is red and girls is blue. Many more girls than boys said no, and many more boys than girls said don't know. And they did a couple of other perceptions also, like girls are not good at science and maths. Many more boys thought that to be the case. So mentoring of girls is not the need of the hour. What is the need of the hour is that all young minds must learn that people of all genders can competently do science. That is the need of the hour. So I think it is misguided to invest in these programs for young girls. I mean, it feels very warm and fuzzy. You know, somebody is having like a math school for young girls, and some physics something for young girls, and a star party for young girls. That is clearly not the need of the hour, and when it is not the need of the hour and you do it anyway, then it can cause harm because you're unnecessarily segregating by gender where that is not actually required, and it is also not a nice thing to do. Gender, as far as the gender gap within the profession, I don't want to again present a whole lot of details because I need to finish quickly. But I did want to come back to Annamani and Vigyan Prasar, which is the DST-funded science communication institution, made a documentary film on Annamani. And I was quite taken aback at some of the statements they made in it. For example, Professor Raman offered her the opportunity to join him in continuing research on fluorescence, an unthinkable privilege for a woman at that time. Now, why would this be an unthinkable privilege? I mean, she was as qualified, or even she was obviously very, very well qualified because she won a scholarship to do her research. It was Raman's privilege that she came to him saying, I want to work in your lab, right? And then there is this thing that this is when she went into the department, the meteorological department, on a war footing and trained a core group of experts, etc., etc. And it ends by saying the department was a hive that hummed with activity around Anna, the queen bee. Okay. And then in 1953, she was promoted to head the instrumentation division of IMND of 121 men. An unusual achievement for a woman at the time. I mean, it's like, you know, her achievement is to be the boss of 120 men. I mean, like, what's going on here, you know? Her achievement was that she built instrumentation to do real science, right? That was her achievement. But they still want to cast it in this, that she was a woman and all her staff were men, which incidentally is not a very complimentary thing for the department, that they were all, 121 were all men. But, you know, it is just framed in such an odd and crazy way. And this, I think, was the last of them. Miss Annamani can well be described as the mother of India's weather instruments. So we are still in that patriarchal mindset. I mean, even Vigyan Prasar, which has an extra responsibility because they're doing science communication and projecting science and how science is done and who done science, they have an extra responsibility to project it as something that everybody does. And this film was made in 2016, so not that long ago. So I wanted to end just to reiterate about the Annamani lectures. They happen quite regularly, so do look out for them, and the older ones are on YouTube. Do take a look at them. Some of them are really good. And I just wanted to show this. This is a cartoon that appeared in Resonance in 2017 when I guest edited an issue with an all-women authorship. And I'm really proud of this cartoon because I use social media to find this woman cartoonist to do a cartoon for the magazine, and I contacted her through social media and got her to do this cartoon. So I really want to show you that. And of course, I think all of you know about this comic book on Annamani that was written by Nandita Jayaraj. And it is available in print, is also freely downloadable, and it's a very cute cartoon, so I'll stop there.
Thank you, Prajwal. Questions, comments? What do we do the next time?
In IIA, there are many women faculty members. Do you heard about harassment in workplace often?
Oh, gosh. Don't get me started, please.
It's the number is much higher.
No, so first of all, IIA had more women than any other institute. It still doesn't have a lot of women. There were about 10, that kind of thing among 50. So that's not a whole lot of women. It just happens to, the other places are so dismal that IIA looked good. There is some history to it, I have to admit. I concluded after my stint in IIA that the fact that I had at least that many women was because of a culture that was set by the founder, which was a very different culture from other places. I think Venu Bapu was far more gender neutral. I think he held women to the same academic standards as he did the men. And he set a culture, very, very strong culture, because I felt it very strongly when I went to the observatory. And so comparing my experience at the IIA observatory compared to the TFR observatory in Ooty, in the TFR observatory at Ooty, it was a terrible experience. We were always thought of as people who came there for time pass, and we were never taken seriously. Whereas at the IIA observatories, we were always, at least I felt that way, that I was always given the same respect that any other scientist was given, right to the very lowest level of staff, to the highest level of staff, engineers, everybody. That was my experience. So there could be something there. Some sociologist, historian has to do a proper study. But it's still not a high number. It's certainly not a case of complete absence of sexual harassment. No, not at all.
When you talked about the school kids, and the opinion of the boys was the girls are not good in STEM subjects. But what is interesting is that in those schools, in whatever schools I know, majority of teachers are actually women. Even physics, my daughter's school physicist, all physics was taught by women. Then how it comes from, where it comes from?
Yeah, so I think there has been a regression. So for example, when I was in school, I went to a girls' school, but the only men teachers I had were for music, dance, and Kannada. All other teachers, including NCC and games, and of course science and history and English and everything, were women. And I don't ever remember women telling any of us that this was not for us and that was not for us and something else was better for us. I don't ever remember that. When I went to college, I also went to a girls' college. There the people were mixed, the faculty was mixed, but again equal representation. 2 heads of departments were women. The only PhD in my college among the faculty was a physics PhD, and she was a woman. There were 2 single women. There were 2 Roman Catholic nuns who were my science professors, and so on. So I thought of science as different, exactly like Annamani did also. Annamani also would say things like, what is this big hoopla about women and science and all that? Because, there is that ambience of, there was a national struggle thing. I was born after that, but there was still that ambience of, egalitarianism as the ideal and all of those things. So we imbibed all those things, and so did the teachers and all that. But I think there has been a regression because science is taught in a very apolitical way. You're supposed to only do your studies. You're not supposed to look outside of it. And also the TV, media and all that is very heavily sexualized and genderized. So I think people imbibe these things. So even women teachers, it doesn't matter whether the teacher is a woman or a man. What matters is, do they have a good relationship with their students, and do they tell different things to different groups of students? So even women teachers are known to tell girl students, why are you studying physics? You're going to get married anyway, and that sort of thing. So there has been a regression, I feel.
Okay, any other questions? Comments?
Just as you mentioned Annamani, I also remember my mother also remarking that she, if you asked her if she faced gender discrimination, she would say, no, I don't remember anything like that.
Right. So even for me, it was when I went to IIT that it first hit me. Until then, I always thought of science as a cocoon, where the societal discrimination doesn't exist. I thought of education as a sort of, progressive, modern thing. Yeah.
One of the possibilities is also what I think one has discussed is this thing that in physics, there is a sort of genius syndrome that we have.
Yeah.
Which is highlighted. I mean, I have nothing against Feynman. I think he was brilliant in all of this. But the stories and the idea that there are just a few geniuses and all of them are men. Marie Curie is never. She was just this hardworking scientist who worked and slogged, and they sort of gave her the Nobel Prize. I was sort of and this idea of genius, of inbuilt, somehow is much more insidious in physics than I think it is in any other science.
Yes.
And somehow, because it's a mixture of mathematics as well as, physical intuition, which somehow only men have privilege to. There's a culture here which I think is also very detrimental to physics itself as a science. And if one sees this genderization of it as something that's actually impacting science and the practice of science, I think that is an into, potentially...
But also it has impacted those who have kind of, despite all this, tunneled through. Like, like if you look at the Nobel Prizes, for instance, Marie Curie, even it was only because Pierre fought for it that she got it. And then there was Maria Goeppert-Mayer after 60 years, and then there was Donna Strickland after another whatever years. But in between, there's Cecilia Payne-Gaposchkin, for example. I mean, hers was a transformational discovery where she showed that, the sun is not made up of like what rocks and stones are made up of. And that really changed our whole concept. But she didn't get the prize. And so there were so many others. There was Vera Rubin, there was Jocelyn Bell, and these are only the physics people that I know of. I mean, I'm sure there'll be so many others, right? So they were denied the prize only because they were women, for no other reason, right? So... Right. Yeah, but I mean, even that second one, it was so bad, bro. She got it, but then she was told not to come to the ceremony because it was said that she is having this affair with Langevin and all that. Yeah.
I also wanted to, point something out. So, the stereotyping starts with very small children. Because I used to be part of this organization called the Global Young Academy, and they had asked little children, to draw pictures of scientists. Everybody drew an old man with, crazy hair working on a bomb. So that's what books say. I mean, absolutely. Yeah, that's the stereotype. There's no running away from that.
Right. So HPCSE has done quite a bit of work on combing the NCERT textbooks and recommending things. I don't know what's going to happen now. And that's why one needs comics like that for young children. Which showcase Annamani and the story of the diamonds and all that. It's very nice. Yes. So
I have two comments. One is that when we are trying to make space for women, and if we are not overhauling the system, if we are not changing the system as a whole, sometimes what we do is that we give it even undue importance, and we just try to assert ourselves in it. Means like you need that Nobel Prize, but so you would not disregard the patriarchal whole setup. You would just try to find your place in it, so that way you also give it that kind of importance. So yes, but changing the whole thing, bringing a huge change is difficult. But sometimes it feels like we are just catering to patriarchy. Like, what is our main focus audience? Our main focus audience is RRI male. They should, see it. They should attend it. So you want appreciation, or you want those issues to be discussed. Yeah. They have to be involved, yes.
Sorry,
yes.
did you said RRI main? I didn't get that.
So I'm saying that suppose you are organizing something.
Oh, males. Okay, okay.
Yeah.
Uh-huh.
Yeah. Then. No, I'm not. Then I have suggested this to her that yes, we should all sit and discuss these things, but we can also have a day where we call women from various schools or colleges, and they can actually see the issues have to be discussed with everyone. That can also be done separately. And also, if we could have a wider audience and we could just show what kind of activities that women scientists do at RRI.
Yeah, so I agree with you that we try to do band-aids. I think don't quite agree that by trying to do band-aids we are making a big thing of it. Is that what you were saying? I'm not sure. I mean, I agree that Nobel Prizes are just a symptom. So we need to fix the system so that Nobel Prizes get fixed, so that young mentoring gets fixed, so that faculty ratios get fixed, and Bhatnagar Awards get fixed, and Governing Council gets fixed, and everything gets fixed. We need to fix the system. And these are all just symptoms. That part I agree.
I'll give you a personal example to explain what I'm saying. So my bhabhi, my brother's wife, they are 3 sisters. So she wanted that when my niece was born, she said that her surname should also be there. So she said that it should not just be Sara Sachdeva, it should be Sara Rathi Sachdeva or something like that. So I was saying that then why are you bringing your father's surname? Why don't you bring your mother's surname? So yes, you want to go against patriarchy, but in that process you are actually being a proponent of it.
Yeah, but in that particular name thing, I would say I would favor choice. It should be it should be their choice, and maybe your comment will make her give it mother's name. Who knows? I mean, my son once turned around and said, "I want your mother's maiden name." I mean, no, he wanted my mother's or my grandmother's maiden, something like that. So it just felt very complicated, and he didn't actually do it. But so the point is, they should have the autonomy to decide whichever they want. In that particular case.
See, one thing I felt that in these institutions and harassment processes, the people who harass, most of the cases men, they don't realize they are harassing. They think they are doing the right thing. So this sense of right and wrong, it is to be established at the beginning, because they are very academically qualified, but the sense of what I say morality is not there.
Yeah.
So the problem is there. They think we are right.
Yes. Yes, that is true.
Yeah, but also they are right, not between, there is a problem that the right and wrong is also that they have authority over women. That's the point. It is not simply a moral issue that whether they are right or wrong. I think it is also that they have authority to judge any woman, any of their peers, which even if they are not qualified to judge, they will judge. And that, I think, is beyond morality. That is sort of a claim, a patriarchal claim.
But it's the way to redress that is to make our governance more transparent and accountable. This is a fairly well-established dictum that institutions have to make their processes transparent and accountable. That is good for everybody. It's not just good for women or men or it's good for everybody to do that. And in Indian institutions, it's a particular, elite institutions, it's a particular problem. There's a particular lack of transparency and accountability. So that is where, needs to address. For example, Yeah, but I can tell you, all of us are brought up to accept sexist thought and sexist action. So regardless of our gender, we are gender biased, all of us. So just having women in a governing council or something, it's a good thing to do because it's the right thing to do. All governing councils should have proper representation. But to expect that that will solve the problem is, I feel, not a good expectation.
So we will have a woman on our governing council, Annapurni Subramaniam. I think she's taking over from, she's going to be there from May.
Quite apart from governing council, if you just look at RRI itself, over the past few decades, there have been several positive changes for the better. There are committees where there are many more women representations, and certainly that makes a positive difference. I don't think it's a step in the wrong direction, it's a step in the right direction.
No, I'm saying that there should be representation because it's the right thing to do, not because it's a step to solving the problems that we are talking about in governance, in gender harassment and all that. They won't necessarily solve that problem.
But it does matter, because in such situations, we do know, for example, in interview committees and other places, that these things and remarks about women come up. So when you have another woman, it really does act as a check, as a fairly decent check and balance. And not in every case, but statistically, it makes a difference.
Yeah, but it depends.
You don't accept the same comment. I'm saying that when you're on a committee, and for a lot of women, we don't accept the same comments.
You may
from
not.
Our male colleagues.
You may not, Sumati.
Many women will not.
No, but many women do also.
No, then you say, okay.
So I'm saying all of us need gender equity education. Everybody needs it. Because you cannot assume that just because a person is a woman, she will be gender unbiased. And therefore, I'm saying committee memberships should be there, should be diverse, because it's the right thing to do. If they are not there, then it's just wrong, that's all. But will that solve the other problems? That is not necessarily true. Because why I'm saying this is that people are now touting this, all our committees, now there's a government rule that all committees should have women. But what Sonali was saying, that the systemic problem, that won't necessarily get addressed by that. Exactly.
That's a good one. She said that's because there are no women.
No, I've been on committees, even on committees where there have been men and the women who are scientists, engineers, they have asked candidates, when are you married, how many children do you have? And then after the committee meeting is over, I tell them, look, this is not appropriate because whatever, you should only give the job description to all candidates and say, is this okay with you? If the candidate is a shortlisted candidate and all that. And they said, no, we are just asking out of concern. It's perfectly fine. So then I had to, on some occasions, I was chair. So I had to step in and say, no, I'm chair and I'm stopping this. That's all. So like being very heavy-handed. But, so there's no guarantee either way. I think gender equity training at all levels is absolutely necessary.
So the students and the young men, would you have anything to say or to add? You're listening, but you're not saying anything. Would you like to say something? No, not yet. Okay. Okay. So any other questions, suggestions, comments? If there are none, I think we'll close. So again, happy International Women's Day to all of you, to all the co-organizers. And I personally learned so much from each one of you. And we even ended up having a panel discussion, which we hadn't really planned to have. Okay, so I think this had to happen, and I'm glad it happened. And thank you all very much for sitting through this. And I think I just spoke to Subbu. We'll soon have this whole meeting on our new RRI website. So, okay. Thanks everybody. Thank you. Oh, by the way, so Sunanda Bai and Annamani's theses are here. So if you want to check them out, they'll be here for some more time. This is from our, it's here. No, we have to return them to the RRI library, yes.
Oh, you have to read it.